Welcome is mine. Good morning, ladies and gentlemen, dear colleagues. I would like to welcome you on this conference about data, artificial intelligence, and robotics. And my name is Michal Trčka, and I am coordinator of this event, organized as a part of activities in the AMULET project, Advanced Materials for Enabling Technologies, and in cooperation with Czech Institute of Informatics, Robotics and Cybernetics. Thanks a lot. Especially with support from project RICAIP, ROBOPROX, and ELLIOT. This event is also under auspices by Academic Council of and Scientific Council of Czech Academy of Sciences, and with patronage by President of Czech Academy of Sciences. The event is also organized with the support of the Open Science Department of the Library of the Czech Academy of Sciences and two programs of strategy, AV21 and media partners, Věda Výzkum, Vesmír, and Academics Review. So that's a really long list with partners. Why D.A.R? D.A.R is acronym, but not only. D.A.R is on the one hand, this acronym means also in the Czech pronunciation dar. It means gift. So the conference has aim to explore some good practices and remarkable advances in science and technology in the field of data processing. But on the other hand, D.A.R is also acronym to, so maybe an allusion to R.U.R, the famous dystopian play of Karel Čapek. And in this play, Karel Čapek with his brother introduced the word robot. But not only this word, also think about modern technology and power and some ethical issues. So in this spirit, also behind you, you can see an installation of Jaroslav Anděl's exhibition, one chapter of this exhibition from exhibition AI and predecessors between facts and values. And in this spirit, the conference want to show also some questions and issues about responsible research in not only data processing, but in the age of AI. It's my pleasure to welcome our first two speakers. The first one is Martin Kalbáč for CIIRC Institute, head of the AMULET project. And the second one will be Josef Lazar, a member of Scientific Council of the Czech Academy of Sciences.
Okay, so thank you very much, Michal. So first of all, welcome and thank you for coming. So as Michal said, so I'm a coordinator of AMULET project, and also I'm vice director of CIIRC Institute. The AMULET project deals with chemistry and physics, but it's a really large project, and we want to also address impact of the materials which we prepare and functionalize and study on the society. And that's why we took on board Michal Trčka, who is actually a sociologist. And within that project, so he is really very active, and he suggests to organize a meeting on open science, which took place during the last year. The open science, in this meeting, we mostly discuss open publishing. So this is very important issue. We can see that there is a bright side that everyone has access to the publications, to the research, and doesn't need to pay for that, which is very beneficial. But there is also dark side, and that is that the researchers who actually produce the data and make the publication have to pay. and the money are not the money are quite substantial. So I think this is important to discuss. But I would leave that topic because there is another part of open science, and this is open data. And in the age of AI, I think it's really important to discuss that. And we have this this meeting here. I think there will be also a bright side of the open data because everyone can analyze the data, and I think the efficiency will be much higher. But I think there could be also a dark side, and I think this meeting we should actually discuss that, because if we want to benefit from that development, so we should understand and we should be prepared. So thank you very much for coming, and I give the word to my colleague.
Well, good morning, ladies and gentlemen. I represent here not only the Scientific Council of the Czech Academy of Sciences, but also a program of the strategy of the Academy, which puts together artificial intelligence and also quantum technologies. I would like to say that when we talk about open data, it's necessary to say that the tools of artificial intelligence are hugely important tool that can create enormous amount of information out of the data that are openly available. That's not doubt about this. And especially when quantum computing is coming, this will be another game changer. But my predecessor mentioned that there is also a dark side of this, well, concept of open data. And I would like to say that in present days we see that something which is a norm in one field of research and is considered to be very helpful for development of science in this field is quite often transferred in all fields of research without any consideration. I am from an institute that is technologically oriented, so what we produce as a result of our research is more or less a technological know-how, and it would be completely crazy to give this openly for everyone. If we talk about open data, we have to say that the concept has to be responsible and has to be ethical. And when we do the research, we do it on the basis of funding by taxpayers' money of this country. And we have the obligation to contribute to the competitiveness of this country in the world stage. And the world stage is not always friendly at the moment. We can see it quite clearly. So I hope that within this, this conference and among you, there will be a discussion that will try to bring answers to these critical questions. So what should we do? How should we operate with the data? Let's say to create a data set is usually very costly, but to use an AI to produce some results out of the data is much less costly. And is it okay that someone else from any other country does this on the basis of the data we create? But on the other hand, as I said in the beginning, the availability of the data is a great tool. In combination with AI, there's not question about this. So hopefully, this is not a set of simple answers, simple questions, and I hope that you will be able to at least offer some answers. So I believe your meeting will be successful and fruitful, and I keep my fingers crossed for you.
All right, so we will start with the first section, which is called AI and Science in AI. And before introducing my guests, let me introduce myself. Juraj Horecký is my name. I'm a philosopher and ethicist from the Institute of Philosophy, Czech Academy of Sciences. And I will be moderator of this discussion. I'm doing technology ethics, so it's not that I'm completely incompetent in these questions, but we will see. I'm happy to welcome on board for the discussion other members of the panel today. Dr. Zitova from the Institute of Informatization and Automatization of the Czech Academy of Sciences, the head of the visual processing unit there. Martin Vita from the Physics Institute, he also is famous among all the people in the Academy of Sciences for heading the Strategy AI 21 program in the topic of AI. And Jan Šediví from this very building, from this very institute, who is renowned expert on large language models, also an entrepreneur in this field, and we expect a lot. Okay, thank you. We'll proceed in the following manner. So we have like over an hour for the whole panel. We will proceed in the following manner. I will start with a short 10-minute introduction, asking some very general questions, as philosophers tend to do. Then each of the panelists will have 5 to 7 minutes to make certain statement, and then we will have a moderated discussion on some of the crucial issues related to place of AI in science and what can science do with AI. And then Martin Vita will have some closing remarks. Are we also taking questions from the audience? Probably. All right. So how do I navigate this? Do I just... yeah. Should I stand? I like standing, so I'm going to stand. All right. So I work in a place that is... where am I pointing? I work for the Center of Ecology, Environmental and Technology Ethics, and today this is our main concern. So on the very general understanding of where is the place for science and AI, the following triplet comes to mind immediately. AI can be seen as something that results of scientific processes as that have been conducting for last half a century or so. AI is also increasingly becoming the object of science. That is, more and more researchers are interested in what AI does. And this is an interesting intersection because it's a product of certain scientific fields to be studied by other scientific fields as the end results of certain processes. And then, that's a topic that I guess will be about our discussion later on, it's becoming a tool which is becoming completely indispensable in the interaction, in day-to-day operations of scientific inquiry. And I will shortly talk about each one of those in order to introduce what I mean by this commonalities. All right. So as just put it all in there. When it comes to the result, understanding AI as the result of scientific processes, it's perfectly well known that had it not been for certain developments in computer science since basically 1950s onwards, we wouldn't be in the state of affairs that we are in. The world of AI and the world in general would not look the way it does. The fact that our past and present colleagues are contributing to the existence of this very subject matter is obviously crucial, but two perspectives should be in mind when reacting to this very recognition. On one hand, there is a certain gratitude as there is for any development of any scientific discovery. But what is more interesting is that as we see the radical changes in science and in society in general, it also brings a specific kind of responsibility. And the responsibility that I'm particularly, as a philosopher and ethicist, interested in are the responsibility in along several trajectories. On one hand, we are the ones, you are the ones who are particularly well suited to answer questions people in your field, outside of your field, or in general public have about the very the entity that we are talking about, AI. The expertise is also tying you to certain responsiveness for the information being provided on what the current state of knowledge is, what the future prospects are, and how to utilize them. Also, that's also tied to the explanation of what is actually happening. So not only telling us what are the underlying mechanisms about on the developments that we see currently, but also telling us in a broader story why things are happening the way they are. And of course, that's tied to a very important element that is, I think, often lost on the users, and that is the very architecture, the very process of development of certain tools is very much, should be very much shaping up the proper usage. And we are still missing this, I think we are significantly missing this link between what the architecture and the original design of this invention is and how it should be properly used. Hello? Okay. And of course, there is a sort of a more visionary element, is that how we, and what is happening now and how we use these devices, but also how we continue in researching it, is very much posed to shape up the future of the field. All right. So when it comes to the, so I'm talking about the AI as a result of scientific practice. Now I'm going to be concerned shortly about the AI as the object of scientific inquiry. And what is rather intriguing for me as an outside observer is very novel perception of how to study this field, this field of inquiry, because it's produced by certain branch of science and it's studied by others exactly because there are some intrinsically unknown elements about how it operates, and that forces us as scientists to learn more about how it operates, what it is capable of, and what it can be utilized for. And I don't really have in mind necessarily the black box nature of which you are all perfectly aware, but what is particularly of interest to me is that we are studying obsessively entities which are coming from proprietary use or proprietary origin of many renowned companies. And it's because of the proprietary nature that we are forced to use scientific methods to discover what these units do, what these entities do, because exactly they are inaccessible under copyright protections and so on. Just think of it in the following sense. When was the last time science as a field was concerned of discovering how products of private properties or takes as its object entities produced by private properties in such large numbers? Yes, it did happen in history many times, but in such a substantive and repeated interaction with products of private companies, I think this moves science into completely novel territory. We haven't really seen this kind of search of what is commercially available and trying to uncover what is happening there in order to move science forward. That's a very novel and into some degree disturbing phenomenon. And of course, that's also related to other things. Given that there are many of these companies competing, the release of these new models happens on a speed which is like difficult to track. I'm losing track whether like what's the current release of just one of my favorites, not to speak of the whole repertoire of products which are out there. And this is creating yet another burden on the side of scientists as to how exactly should we follow the speed of development that is just mind-blowing. All right. Finally, I want to say a few words about using the AI as tool for science. And I'm taking the Ouroboros picture not to be just an empty metaphor, but something that is really disturbing me as an outside observer and somebody who is concerned with the practice of science. Because what is happening already is that AI is entering research at all possible stages of its development. It conducts experiments for us. It suggests ideas for the experiments. We use it for writing, editing, shaping papers. It's used heavily in reviewing papers and deciding which ones will or will not be successful in the field, in particular fields. And then it's also used for reading and summarizing the papers. So we are really doing the full circle of everything from production through shaping up to consumption. Everything is done via these tools. And that's once again something which we have not seen in sciences before, and it opens up serious questions about what does it mean to do science as a human endeavor. All right. So what is also, as an ethicist, what is also disturbing is that the speed that I was mentioning before gives us very little time for reflection. We are seeing these developments rapidly out there. We are trying to keep track of all the releases, all the updates, and what they mean for us as users. But we have little time to think about the broader implications for science and scientific practice, for scientists, especially in different fields. And Professor Lazar already mentioned that the track of uptake in different fields is very different. So are we going to be seeing differentiations across sciences across this particular axis? Also, what is particularly of my concern is the education of future generation of scientists, because it seems more and more likely that alongside your standard education in molecular biology or nuclear physics or so, you will have to also have education on the tools, AI tools that help you produce your science correctly, which was once again not the case a decade ago or so. And of course, it also means something for a broader perspective of science as a public endeavor, as something financed by the governments and by the public, and that is the public understanding of science. Are we making science more trustworthy or less trustworthy by indulging into this Ouroboros? Autophagy is the term that is currently used for these sort of self-consuming elements of AI using science. So much for the brief intro, and let's just talk about this. So I will now kindly ask my colleagues to reflect and to have their own perspective on the issue.
So I will start. Thank you very much for invitation to have possibility to talk some of my views here. As it was said, I am the head of image processing department, so we are processing images, and in image and video processing, the AI entered quite early, and so people had to accept it because either your paper is mentioning AI, using AI, or testing against AI, because otherwise your paper is not going to be accepted. So it's already years. And so based on this experience, I'm going to talk about three things we are involved in our department. It's not nothing special, but first data are here first as well. Recently, when I went through the index report on AI from Stanford University, there is a graph showing that actually for training networks, the percentage of data used for the training comes nowadays more from the synthesized source than from the real data, which is kind of surprising because probably all of you remember all these papers that if you will use the artificial data, then the method will collapse, and etc., etc. So I think this is the way how we can get out of the valley, because to have data, to ask doctors to label data It's very complex problem, and they, no specialist has any time to do this for us. So I think this is the way how many new methods, many new applications can be produced. And I will mention 2 examples from our laboratory where this artificial way how to create the training data helped a lot, and it's really working. One is the images of rods with nuclear material from nuclear power plants, because it's really difficult to get pictures of this. I mean, it's just 1 day per year where we can take pictures. And in this sense, the method was designed that all the damages, some influences which can appear on rods were simulated, and the method was trained, and now it's really working. We have 2 patents, and nuclear power plants from all over the world are asking for our help. So this is like a success story where even that we didn't have the real data, it helped. Another story with the data where it can be very useful is in the case when we don't have the ground truth data, because if you process the microscopy data, how you can judge if your algorithm for improvement of the quality works well when you don't actually know how it looks like, because you don't have any tool to see the real situation. So in cooperation with the Cambridge University, we developed algorithms where the methods, the AI methods, were trained on the artificial data, on the synthesized data, and it works, and it really gives good responses on the real data, and the method for tracking how the cells eat and how they do the opposite action can in the end help with the development of new medical treatments. So we start with simulations, yeah, like computer game, let's say, but at the end it will help in a practical life. So this was about data, and I am really looking forward to a situation when we are not like bragging that we don't have enough, we need more, because now we can produce our own data based on our knowledge of the real situation. The second topic I would like to cover, we actually discussed it with my colleague here before this event started, is about how much AI can invent something and how much it is important, or what is the lesson from this. I'm talking about this case. It was at the end of the last year where the RDosh problems, one of them was solved by AI. It was all over the media. And when you actually dig into this topic, you realize that there are some side effects which maybe explain why this RDosh problem was not addressed properly before by humans, because the definition of the problem was not proper. And after publication, actually some authors of a paper from 2014 wrote to the AI people that he actually wrote something similar. So maybe the AI model started on this idea, and maybe it's not such an invention as it was claimed. But the lecture from all this is, I think, totally different, because there is a nice blog from Terence Tao, a very famous mathematician, who was addressing this RDosh topic. And he said that for him, it was much useful to gain the knowledge how easily he can use different AI models to reformulate the problem, to reformulate the paper, to explain the methods from different point of view, which I think is very useful, because nowadays, when you want to publish your paper, you send it somewhere, you get the response, but you usually don't rewrite the whole paper from the new point of view. So I would say that here, I agree that from the philosophical point of view, it's good to know if AI can invent something, but definitely AI can help us to write papers in better manner, so more people can understand what is written in the papers. And moreover, this is actually the thought from Terence Tao as well, that if you do the research in a very narrow area, in some special niche, AI is very good tool to find you, to provide you the references to do research. Because if you work in some main area, then you have thousands of papers and you can read citations and follow the way. But if you come up with some new tiny idea, then it's really difficult to find papers if there are some relevant, etc. So these two approaches, how to use AI models, I think it's very useful for science. Science will probably go faster by help of these tools, but it's not like AI is actually inventing something. It can help you definitely, but that's not what I wanted to address. And the last topic is about students. I know that the conference is not about education, but actually it starts with students. We have some students nowadays who are like, I imagine them as sitting on the wild horse of AI codex or Claude code, because they are so fast that for, let's say, older colleagues, it's very difficult to evaluate if what they are producing has some meaning or not. And I think this part should be addressed as soon as possible, because they are very good. They are very good in handling the AI models, coding models, and they can be very helpful in the scientific departments. But somehow somebody has to tell them to like stop, to think more, not to go so wild, because it's not actually the sprint competition. Yeah? I mean, in a way, yes, from the paper point of view, but I believe we need them a lot, because they don't have these fears to start with some new coding tool. But in the cooperation, AI youngers and, let's say, more experienced ones will form these best teams who will bring up new ideas and new papers. So this is last thought from my side. Thank you very much. And I'll pass the microphone.
So thank you very much. I would like to express my thanks to the organizers for inviting me. And I'm going to start this discussion from my side with my personal experience from the last year. I tried to study one particular paper which was interdisciplinary. It was something between biomedical sciences and machine learning. It was about predicting some immune response to some particular biological treatment. And on this particular experience, I would like to point out several issues. The first step I've done was just asking ChatGPT to summarize the paper and explaining something what was completely new for me, so the biomedical part. And together, along with these prompts, I asked also one agent to download the underlying data and to run the scripts, Python scripts and Python notebooks, and try to reproduce the results. And I was very surprised that the results which were produced by ChatGPT were completely different from those numbers reported in the paper. And so I did it on myself. I run the notebook by hand, and I have seen that ChatGPT was correct and the numbers reported in the paper were wrong. So it was a big surprise. And there's a natural question what to do, and how can be this phenomenon useful. So I tried to consider not running these kind of agents for checking only one particular paper, but a series of paper, maybe the whole collection from the journal. And I didn't do this, but it's, of course, appealing idea. And in general, I think that AI agents and these technologies can help us to sanitize, to do something like sanity checks. of today's knowledge. This is the first issue I'd like to address. I'm going to focus more on the part of AI for science and not science for AI, because in science for AI I'm not so competent. I'm just an average user, average machine learning guy who uses standard methods and training models which were invented several years ago. So I'm going to talk about AI for science. So this is the first chapter which should be opened. Currently, I'm reviewing dozens of papers from I can say average level conferences, and not top tier conferences, but there are different policies of using AI for review process. But I think that there is a general, I'm convinced that there is a general requirement in science which says that we should be reliable, trustful, correct as possible. And if some tool can help us, like AI tools, we should use them. Yeah. So I think that this is something like a moral duty to produce the best possible results, and therefore we should use tools which are available. I'm going to act here not as a representative of our strategy AV21, but also like a techno-optimist here. So it's a part of the discussion. The next issue I would like to point out is that LLMs or AI tools can help us to foster interdisciplinarity. Nowadays, it's pretty difficult to find an expert who is an expert in, for instance, economics and in physics together. Also, there are some, but it's not so common. And I'm pretty sure that some concepts which were developed for physics, for theoretical physics, are also useful, for instance, in economy. But it's difficult to exploit the knowledge in physics in a different field where researchers usually do not have basics of physics. And this is another opportunity for using AI tools to foster interdisciplinarity, to exploit the knowledge from several scientific fields. So this is another idea for discussion. And going back to my personal experience about reading a paper in AI in biomedicine, I think that the time of standard papers, as we know from the history, is being over. Yeah. If I go through the standard structure of the paper, there is usually some introduction. And for instance, if you read a paper from multidisciplinary field and you are an expert in one field, you usually feel that from your field there are some trivial remarks, trivial facts. So it's I don't know what to say, wasting of time, but it's not so inspiring reading. But from the fields you are not expert in, it's usually too difficult for you, and you need explanation. And my idea is that the style of standard papers will change a little bit. For instance, the part like state of the art and introduction will be personalized for you, for your point of view, for your knowledge. This is one part. The core of the paper will be based on the core idea, data, and results. And of course, the wording and paragraphs of text will be instantly generated for you. So this is my my idea for discussion. And the last thing I would like to mention is that vibe coding practices and agentic AI and AI tools can democratize doing research. For instance, if you imagine people working in humanities, for instance, for example, if they wanted to incorporate some statistical or data science methods, they needed to incorporate experts in this field. This was the only way how to do it. But now, using some vibe coding approaches, they can replace this job in his or her team and do it on yourself using AI tools. So this can help people who have ideas and no experience with coding. So this is another benefit or advantage of using these tools in science. So as I've mentioned, I'm a techno-optimist, and that's all for me for this moment.
Hello, everybody. Thank you for being invited. And I don't know what to say after what I've heard. It's everything has been mentioned. So many questions were raised. So there is plenty of room for further discussion. But let me introduce myself a little. I am not really this basic or scientist who is looking into deep science. We are more like a scientist or applied scientists. My team, as has been already mentioned, I'm from this building. So this is CIIRC, and here we have lots of students as well as a lot of employees. And my team is working in the field of say large language models, or we are using large language models these days. We are running several projects, but the unifying idea is to kill our largest enemy, which is bureaucracy. So we are trying to actually build applications which would make the administrative job much more productive. We are discussing with Andrzej whenever we meet. I'm always complaining about something. And the other thing, these things we actually do for industrial partners. So we try to talk to people, meet people, and first of all, to understand what is the problem. Because I was trained, excuse me, I was trained as engineer, and the main idea of engineer, as I understand it, is to solve problem. To use the latest results of science and apply them and help people to do things or accomplish things simpler, easier, better, etc. And this is what we try working with our partners. Besides, we are sort of self-funding, so we have to make money to pay for our rooms and all the other utilities. And in the field of science, which is the other part of my team, we work on training, or actually not only training, but designing systems for generating code. We are lucky that we work in, this is basically a competition for teams, which is organized by Amazon, and we already for 10 years. Actually, this year it's a 10th anniversary of working with Amazon. So we these days work on generating language models for producing code and producing code without vulnerabilities, exploits, or not trying or not generating malicious code and so on. So this is bringing us great benefits in terms of clock cycles or free clock cycles to be precise. So we are really enjoying that, and the team works like 24/7. I am happy that the students are not at home but coming to this building and spending here a vast of time. So this goes fantastically, and it's a really experience. So by the way, can you raise your hand who is using or who had ever experience with Claude Code? Oh, okay, some people. So, you know, then I can say the joke, and it was already mentioned that it's a little bit tricky to use it because I always press one. And this makes the code we are generating sort of, I would say, iffy or maybe not very trustful or whatever we will call it. I believe that in the further discussion we will get back to it. So we are using it on everyday basis, and it is like 4 or 5 months ago when this product has changed the world, because today you know, solving the problem, and it was mentioned here already several times, I only will repeat it or look at it at slightly different angle. So when I get to a point when I understand what is the problem we have to solve, which is like most of the time, it takes very long time to understand what people really want to solve. They usually come to us and they say, we are company X and Y and we need to introduce AI. And I ask them, okay, so what's the problem? What do you need to solve? And they say, it doesn't matter, we need it tomorrow. So, and that's the fundamental problem, that we have to actually dig the information out of them and make the information usable or practical. Then we can use these wonderful new systems to generate the code. And as opposed to, I don't know, a year ago when we spent quite a lot of time to do the application, these days we can do 10, 15, 20 applications, each of them slightly different, and then introduce it to the users and ask them, so what fits best to your needs? And then this actually allows us to do this stuff much better and achieve much better results. Certainly, there are millions of questions we can raise about how to develop and what to do next. And yes, it has been mentioned here, we do the application, or the machine generates the stuff, say, in one afternoon, and then we have to spend like 2 weeks to do something what used to be called pair coding to make sure that it's really what we wanted, and testing it, etc. So this is what is on our mind, or on my mind as well as my students and my co-workers, and this is the direction we are moving. And I will probably conclude this introduction speech by raising a fundamental question, since the leader of, or moderator of our discussion is a philosopher. Then I would say that the fundamental problem of artificial intelligence, or maybe I would say machine learning, is what is the truth? If we knew what is the truth, you know, then we can do verifiable rewarder, and we can use RL, reinforcement learning, to create much better stuff. So this is my contribution to the questions, and yes, if we continue, I can talk to any of these like 4 hours. Thank you.
Good. So pretty amazing array of opinions here. I'm going to start on something which was really going through the contributions of all of you, and that's the issue of trustworthiness. So when I was educated in doing science, or my general understanding of how science came about, always touched very strongly upon the issue of trustworthiness. Science is supposed to be the endeavor in which reliability of the conclusion, precision in testifying, verifying, justifying any conclusions and any intermediate steps is of absolutely crucial component of arriving to the eventual outcome. And what does that mean is that you are only reading papers from reliable sources. You are only going for procedures that are well tested. You are reviewing or sort of discussing any outstanding problem with as many possible collaborators as possible to sort of arrive at the unbiased opinion and so on. And it seemed to me that many of the suggestions that were mentioned here are strongly going against that trend. We have heard a lot about synthetic data. There was a no-go just years ago. We have heard quite a bit about maybe a fabrication in the case of data that Martin has encountered in the biomedical journal. Vibe coding has a problem of its own. I myself am finding that in order to keep track with what's going on, I'm reading more and more previews of the papers as opposed to something that underwent a rigorous review process. And it seems that all these processes are becoming a norm of what the current scientific practice is, because AI is allowing this all becoming possible. So how are we to ensure that the data, processes, interactions, tools that we operate with are eventually coming up with the results that other scientists can rely upon, that technology can be built upon, and that the society can utilize the way traditionally science has been used for?
Okay, I try to make it short, but certainly this is one of the fundamental problems. I think that the scientist's career is built on writing papers. This is the basic stuff. What is happening today? Today, you can generate, based on your results, if the results are correct, a paper very quickly. It is very different to what it used to be. And then, but the problem is that the process of actually reviewing the paper is still very slow, and it takes quite some time to actually evaluate the paper. So if you want to really understand what is in the paper, and if you really want to verify it is correct, it's very difficult. And I think that one of the steps we can take is to try to find some new institutions or constitutions or whatever for making the paper reproducible. Because if there is a reproducibility, which is very, very difficult because the models are non-deterministic and models are being developed very quickly. But if we can make the stuff reproducible, that would be the first step to actually see whether what is mediated is really correct. I even believe that that the people who would actually verify that the paper is correct should be paid for the effort, because it is definitely taking a lot of time. And if this would happen, then certainly we can maybe make the number of paper, it's an inflation of papers, all these predator editors and so on. There are so many papers, and it's impossible to go through it, and to actually distill what matters and what not is very difficult, and certainly we can use models for it, etc. So we have to actually change the way, as we has already mentioned, change the way how the scientific process will be organized. In my view, and certainly you may not agree with me, we even have to make, and you mentioned it, we even have to make the papers shorter, because for me, when I encounter some paper, maybe like 2 sentences are significant. The rest of it I know. This is not that I know everything, but this is that I am reading only the very narrow field where I have read it, or I am following it for decades. So I know what's going on basically for high level. And then to find the trick, the person is actually telling us it takes time. So I have one of the member of our team has created an agentic system which actually reads the papers from RICAIP, where there are these papers published everybody who has something new puts it on RICAIP, and the system is actually deciphering the article, trying to find out where is the description of the algorithm and where is the testing set. The next step is that we ask the LLM to actually generate the code. Then we use the testing set and we are rerunning it to see whether the results are actually correct or not. In many cases it works, in many cases it doesn't work, but it is one step for us to actually go through the articles. And I think that the reproducibility, and I will stop here because there are other steps I would suggest, but the reproducibility is one of the key moments we should try to focus at.
Okay, thanks. Well, I have one note, not about papers, but more about code, or let's say the work on computer. I think I found very useful this ability nowadays of the models to provide scientists these AI agents in swarms. So you have like not just one, you have a group, and you actually can run them against each other. So they are competing, they are producing better results at the end. They can check by themselves, and you don't need to sit there and check if the program works correctly and then report the bug. But actually all this can be done automatically. I'm not trying to say that this will provide definitely the correct code or correct application, but definitely it will make it faster because it will remove the basic bugs or basic problems at the beginning. And I think that that is the future, that you are not working actually with one model or with one agent, but you have more dedicated to specific functions, and outcome will come faster. But definitely you need to be the one who is able to scan through the outputs and understand the outputs, which brings me back to the educational system, because sometimes I have a little bit feeling that this experience, let's say, it's difficult to gain nowadays, because the experience comes from the hard work, which students don't like to hear, but in fact, this doesn't come from using the AI models, AI agents to help you.
Yeah, thank you. One more remark about reproducibility, which Hansa mentioned. A couple of weeks, I read a paper about reproducibility in social sciences, and the authors presented an experiment. They collected a corpus of I don't know how many social sciences papers, and with the data, underlying data, and they showed to agent system the data and the paper, but not the code, which was a counterpart of the papers. And they asked the agents to create the code, particular code, which will achieve the results which were presented in the papers. And the agents created the code, which led to mostly to results which were presented in the papers. So it was clear. But what was interesting, the small amount of papers where the code led to different numbers, different results, and it was an idea that it indicates somehow that the paper was not clearly written. And if the authors improve the paper, then they will allow the agent to code it better and achieve the same results. So this is another way how to improve papers. Because if something was not clear in the paper, the methodology using particular settings and so on, so it should be incorporated in the paper, and it will lead to better results. So it can be considered as an indicator of what to improve.
Okay, to students, I think that no matter how many AI we would have, and no matter how good will be Claude Code, it's impossible to use these systems unless we understand at least superficially the problem. So the formulation of problem, when you use Claude Code, you have to start with creating something which is Claude MD. Claude MD is markdown markdown file where there is written what needs to be put together. And to do this, you have to understand the system. So what I just said is that we have to teach the students to do or to understand how to put the systems together, because translating the description of the system and what it should do to a code, it's maybe in the future very much automatic. I probably even would push the idea up to a point where there won't be any language like Python or anything like that. Maybe the machines can translate it directly to what is used to be called machine code. Nobody does assembly language these days, but you know, we probably can skip Python or other languages which are a semantic form for writing the algorithms. So, but to emphasize what I'd like to say is that unless you are able to describe very well what the system should do, it won't help you. So all these messages like I create the application in the afternoon and it's fantastic is sort of hiding the fact that the person is thinking about the application or was trying several experiments before he has done it in one afternoon, that he was thinking about it several months and understood all the nifty details which have to be crafted in the code. So we shouldn't be, you know, that superficial that the students these days will do everything just with the language models. Yes, any scientist as well as student have the benefit of discussing with the language model, and the language model can bring some ideas which are inspiring or can make us aware of something we haven't put into the task or in the formulation of the task, and that way we can improve it. So the things may go faster, but still we have to understand overall where we are moving. And this is certainly related, and I think that the discussion will go there whether the machines can invent anything.
Thank you. One more remark. I've observed in my case a special kind of, I can say, intellectual laziness, because when writing the code, because I write a couple of lines of code and ask GPTs to continue and describe the ideas, use Claude Code and so on. And I'm not definitely not using Stack Overflow now, because it's a wasting of time. For me, it's more convenient to do this. But you know, we can appreciate, and we are glad we have Claude Code and Codex and other tools like this, because we already know does it mean to code? That it's a hard work and so on. And but what about people who are not in touch with the path, starting with basic programming, not in assembler, but in normal programming languages, and maybe there will be some hidden problem in this, because there will be a generation of people without this background who uses LLMs for programming from the scratch and not having the background. So I don't know what to do in this case.
That's actually something that I want to push back on you guys in a following sense, that it's for us people in the humanities, it's something of a terrifying vision that all the science is becoming a data science, which used to be the case for so many fields for so long, but now it seems to be all collapsing into this like one single strategy as to how to pursue science. And that turns me into the point that has already been suggested by Martin, that gives a certain specific advantage to certain fields of science as opposed to other, because of course it's beneficial if you understand the underlying processes behind programming. Yes, I can vibe code anything, but as a philosopher, am I sure that I have sort of even a remote idea of what the security of the application is that came out? It seems reliable, it seems well utilized, but like, hey, how do I know about leakages and you know, adversarial attacks and so on that the device can be susceptible to? So what I would push on you is like how to make this. Is this a hype that be resisted, or is something that is necessarily just overflowing all the fields of science and there is no way out?
Well, I'm not sure if I'm going to answer your question, but for me it seems relevant, so let's go. Because next to my computer vision and image processing part of work, I recently, I'm time to time involved in explanation of AI to public, to lay people and to students, etc. And I realized that very often for people it's pretty tough to imagine that when you don't know how to handle the AI model, to ask model to help the person with this handling, to go to this meta level. That you don't know what to do, you don't know how to check if your application has some leakages and some security issues, that you should just go up one level and ask, okay, now test everything. In fact, the one of the first recommendation when you start using this vibe coding, or let's say AI engineering, how it's called now, is to start to plan. And in this planning system, usually the AI model comes up with the idea that you should test this and that, and there are some issues. And I was surprised because I was developing application for the Slavic Institute of Academy of Sciences. And when I was doing this planning, because the images which they will be creating is actually you are using the tokens, the API interface, and the Claude code proposed to have the dashboard for pricing, if it doesn't go away, etc. And this was something which actually for me, it will appear probably the idea, but not at the first moment, because pricing, it's like I'm trying to solve scientific problem, so the money doesn't are not important, which actually they are very much very early. So I don't know if it answers your question, but I think we need to be able to ask for help. And I understand that there can be models which are inherently evil and devil, but I'm as well tech optimist, so I hope it's not the case. And in many cases, it will help. And one last note, I still believe there are people for whom it will be difficult to use even these AI models to create application or something. And as the key feature, I found, for example, the game when you should guess animals. Think about animal, the friend asks if it has 4 legs and how big it is, etc. And I realized that very often there are some group of people who start as the first question, is it dog? Yeah, and it's not a joke. Yeah? For some people, really, to cut the feature space in efficient manner is not something inherent. Yeah? So this, I think this goes to the primary school where they should probably run this type of things. But as my colleague thought that actually the software companies will disappear because everybody will produce their own applications using vibe coding, I don't think so this is going to happen because not everybody actually likes it to do this. And not everybody are, let's say, gifted to do this without some extra education. So,
I'd like to get back to the idea whether the data science is, or whether everything is changing to data science, and I'll get back to the beginning. Data science is basically the way to finding the truth. Because the more, there is no better data than more data. This is what one of my bosses said like 30 years ago. And yes, this is giving us some answers. Certainly, we can be misled anyway, but that's what is happening. And then the question to how trustful or how good are the systems we generate with the help of these days systems. Certainly, there is an established way to create applications in computer science, which is test-driven design. And the test-driven design can be in full simulated. Maybe the word simulated is not correct. I should say executed using the language models. And then, besides of that, you may recall that recently in the medias we had heard the reports about Mythos, the latest model from Anthropic, and this model found errors in BSD Unix, which is like 30 years old system, and the errors were, or the bugs were there since the beginning. And yes, there are new papers or new companies, like a new company, D.A.R, here from the Czech Republic, where they are showing that they can find these bugs with a system based on very, very simple, smaller language models, and they find it too. So I think that as we go ahead making the applications, the same way we are improving the debugging or making the systems more reliable, as well as not introducing errors or being, giving the users the ability to do, I don't know, prompt injection and jailbreaks and all of this. So we are making the system being robust and not allow this nasty behavior. So I think that this is the journey we follow, and I won't be that afraid. And I am very happy today that we are discussing the positive sides of AI, because most of the discussions I took part in, there was always like claiming that the doomsday is closer and closer and so on. So I am happy that we look at it positively. Yes, and maybe the last thing I have forgotten, as you said that everybody will do the application. Yes, I am happy about that, because the user interface prefers natural language. So people are able to formulate it, and anybody who is an expert in the domain will do better application than the programmers. Because the person with the experience in the domain can much better formulate what's required. And that's fantastic, isn't it? Yeah, I like it.
Perfect. So I'm being told that our Zoom is bombarded by questions, which also gets me to the fact that you yourself can ask questions. But before you prepare them for our guests, I'm going to ask the technical stuff to maybe project some questions from Zoom on our board, and we can read them. Okay, even my very good glasses make it difficult, but I will try to. Okay. So could we discuss the transfer of scientific knowledge via using AI to abroad? Don't you think? No. Yeah, so this is actually something that I wanted to ask myself. How do you see the security of these tools, the geopolitical considerations, the possible leakages that happen in the past, and how to account for them? What does it mean to have secure tools nowadays when most of them are proprietary, owned by companies with relatively unknown structure, and so on and so on?
I think I said something about the security, but I would add something about the fact that the models are coming from US or from China. There are almost no models coming from Europe, and obviously the models coming from the US as well as from China are bringing in the social biases. So the models, the last stage of creating the models is the reinforcement learning, where we give the system certain features or certain habits, and this is under the control of all of these large companies and the people working them, and these are only a few, very small number of people. These are hundreds of people who work on it, and these people are paid by I would use the dirty word capitalists, and they may have a completely different idea where to go than we have. And certainly the cultural bias in Europe is very different compared to the US, and not mentioning China. So that's all what I would contribute to this question.
Well, I completely agree with Honza, but I would like to add maybe the fact that this topic is really hot, and it's an object of research. So if something some dirty trick appears somewhere in the training and so on, it will be more it will be early captured soon, I think. That's my opinion.
Yes, certainly all these errors in languages, this is all on the internet. As soon as some problem in a system is found, it is listed in special sites, and there are scanners, and these scanners are ingesting all of this and making use of it. But it still doesn't mean that it is perfect. Whatever concerns AI or machine learning, it's never 100%. As well as if you cross the road, you have no 100% security that the car wouldn't hit you.
Do we have questions from the audience? Many. I'm gonna
Okay, thank you very much. André Meyer, Institute of Philosophy. Well, about the security, you mentioned just cultural feature, but here we are thinking about the political features. So I think it's probably very different story. So and also another question, maybe naive. What about some sort of hacking these systems, or the problem of influencing them in a let's say wrong way, where wrong must be specified a bit?
Well, I think that this is a never-ending story. When these systems were launched, of course, there were attempts how to do something bad, some script injection or anything like this. and of course it's a competition between bad guys and good guys, and there is no winner in this moment.
I wouldn't be that much afraid of politicians because they are still letting themselves the emails to be printed out on paper, as we know. So, well, I don't think that they are that much different, you know. But so, anyway, but clearly, as an example, what you can do is, let's suppose that there is a retail store and the retail store sells, I don't know, jewelry or whatever. So the well-known jailbreak or the malicious behavior is to talk to the system as long as it gets and ask for cheaper and cheaper price. At some point, you break in and you will get something which costs like $2,000 for $10. So this is what we have to prevent while making the chatbots or while making the systems. And the way how it is these days handled is that we create something which is called a guardrail. Guardrail is, again, a small language model, or usually much smaller, in the order of single billions. And these models are trained to actually select these very malicious things at the beginning as well as at the output. Because if it's a system which works, for example, with the data from the internet, it goes, searches, as well as Google gets the data to the system. And of course, there is lots of biases in the content which is brought in. And then the system may use this and may output something which is, again, not politically correct. But how to train these things, again, this is a problem. We don't know what is where is the boundary between politically correct and incorrect, which is like different at different places of the world. And we don't know what is the truth. I have to get back to it again. So we can take it offline, but you know, everybody is doing as much as they can to protect their systems and protect users. Protecting users is probably much more important, because they would complain and the media will be happy someone is complaining and so on.
If I can add to this, I think if we take the current AI models, which supposedly are not infected or hacked or whatever, they still can be used in very bad manner, yeah, to like trolling and creating this single spaces for everybody. So I would think in this way, back to education and that people know what can happen. And I think it's difficult, and I don't want to put this doom stuff here because it's very, very connected to this, but I mean, as I said, time to time I talk to media, and I'm really surprised that these journalists who were sent, so I guess they know something about it, what type of questions they are able to ask. So when the media, the representatives of media are so out of everything, then it's difficult to judge what they wrote and how the public opinion is created in this matter. So
maybe to even alleviate the optimism I can sense here around, I think that what would be fantastic if we can, and this is about education, if we can manage to make the Czech Republic the super country where we would distinguish from the rest of the world in the ability to use the artificial intelligence the best in the world. All the citizens would be capable to actually dig out of it as much as they can. And it's education, and this is where I would put the money. Yes, I'd like to have Gigafactory too. It would be fantastic to have lots of, I don't know if I should say free clock cycles, because nothing should be free. So, but if we had the ability to work on the models, but what I believe is much more important is the ability of people taking advantage of it, getting themselves more productive, more useful for the society, and increasing GDP.
So we have a bunch of hands raised. I will try to be sort of just in distributing the questions, so one of them will go here.
Yeah, thank you very much. My name is Aurel Gabrish. I'm from the Czech Technical University, the Faculty of Nuclear Sciences and Physical Engineering. I'm a theoretical physicist by training, and now I work on quantum computing. I'm also leading some educational projects in quantum technologies at the European level. So I wanted to have a comment regarding the education. The way I see, especially LLMs, is that these are soft skills. And to complement what was said before, we can't rely only on soft skills. We need to have the hard skills in the education. And when we talk about how we should transform the education, the question is, what is the amount of hard skills that people should learn? And it is going to be a challenge here in the Czech Republic and this region, because especially in STEM education, the focus has been only on hard skills. So the question is, how do we transition from even including soft skills and then finding the right amount of hard skills that the students need? But I actually had a question, and that is because I'm also a scientist. So this is related to maybe the first point. And first, I would like to make the distinction between science and research, or scientific research and any other kind of research. And then to your points in the first, maybe the third one, do you think that AI can create new science, like create and science? Because we know that it has motivated a lot of research. But do you see that AI will create new science?
Too many questions.
So I can start by saying that if what you mean by creating a new science is creating a new field, I mean, that sort of gets to the big question that I keep avoiding, and that's the question of the truth. But if the world is parceled in certain way, it seemed to me that we have not really uncovered all the possible interactions with the world yet. And if there is this device which can produce, which among other things is generating novel ideas, then hey, why not? It's just, the point is that it's very difficult to ask the kind of questions that for which you don't know some sort of a tentative answers already, because you might be throwing questions which are completely nonsensical and they seem novel, but hey, there is no decent answer to them. That's not very helpful. So, you know, the issue of what is genuinely novel is a perplexing philosophical issue that you are touching upon, and AI might help, because AI, I mean, for me, the term generative AI is like the notion of generation is extremely important, and people forget about the generative element in that. And for that, like, hey, why not?
If I can answer or put my thoughts on this topic. Some years ago, the leader of the Czech Academy of Sciences visited our institute. It was like 3 years ago, I think. And she claimed that the AI cannot bring new ideas. And then I started to think about it, what it actually means new ideas, because at that time she was there. There were papers that AI models came up with the new ways how you can multiply efficiently matrices 4x4, etc. And now we have this paper from the DeepMind model Alpha Evolve, which actually they claim that the method by itself came up with the greedy algorithm and other algorithms, because it was trying to solve a problem, but not by solving, but developing the methods which would solve the problem. So new methods apparently were involved. And when I was trying to come up with the idea what it means that the new idea is not the result or combination of existing ideas you learned before. Yeah? So, for example, with the multiplication of matrices, I guess if you know the systems, you can try like exhaustive search of all possible methods and you came up with something new. Yeah? But then you have this example, as I say, for example, Isaac Newton sleeping under the tree and the apple fall down. And this, I think, is like a new, yeah, maybe because he got the new impulse, even though probably it was not true, but anyway. Yeah. And I think if we try to ask chatbots or AI models to find something complementary what we have, maybe it could come with something new. That's my opinion, because I was trying to answer the question in under which condition this will appear. Yeah, because I think it's not like you ask for solution that probably the model will go through all the info it has. Yeah, so maybe ask if you know something which people don't discuss at all. Yeah, so like the complementary, the null space of the ideas. But I have one more info on this topic, which I recently read on internet, and this is kind of scary because they said that there is some paper apparently that they analyzed how much discussions on internet on new topics or side effects or some boundaries of solving different problems is still present and is decreasing because people don't discuss with each other in certain amount as before, because now you ask your model at home. And, they claim, the author of the paper claim that actually this kind of common knowledge will decrease, common knowledge generated by human people, even by help of AI. But if we stop discussing it publicly, so then the models will not have ways how to fetch the information. And yeah, so this is not like something new will appear, but maybe something will disappear actually. Yeah, so it's like the side effect of this. Thanks.
Well, but these discussions will be covered by the cache of chatbot systems. So I agree with the whole content what Bara said, and as Hansa mentioned, it's pretty easy to ask a chatbot to create a reasonable looking paper now. But I'm sure that real breaking discoveries, scientific discoveries, are something like outliers. And this will remain even in the case of using AI tools. Yeah. Well, sometimes it will be an outlier after providing some context, some special context to the large language model, and maybe there will be some interesting discovery, but in most cases not. So again, it will be a very rare event. Yeah, so that's my perspective. So we will be facing with discoveries produced by humans as well as discoveries with some certain value done by LLMs or some AI tools, and this will live together, and both parts will be outliers. This is my point of view.
Space for one last question, somewhere in the back there. Or you were first. No.
Mirko Navara from this building. I want to respond to the suggestion by Jan Šediví that reviewing should be a paid service. And it already starts. And the commercialization gave new features. It makes the process speed, which is nice. It works well. There is somebody taking care of reminding you, you have to submit it and so on. But there is also a negative effect because there are really even commercial reviewers who do their job for money, not for the truth. It happened several times to me, that I rejected a paper because there was a big error or nonsense. And then I saw the reviews of other reviewers. And I saw, publish as it is, that's nice, and so on. So I know that some people did very little job for the same award, but there's at least some initiative going against that. And we must expect that. Evaluation of reviewers. How useful their reviews were as a feedback for this not to prevail. Thank you.
Yes, this is very nicely folding up our discussion, because we are back at the beginning. What is the truth? And what is the ethics? And this is what you actually pointed out in your question. And clearly, this is something what is the humanity's nature. And this is a question for philosophers, how to make the society more truthful, because you know, LLMs might be or are many times by media called weapons, but knife is also a weapon, and we can every day we use it for our benefit, meaning like positively, and the same is for anything in the world, and probably you would wrap it up much better than I do.
I would love to. I have lots of opinions about detrimental effects on this, on individuals and society and so on. But I mean, today we are sticking with the positive stuff. So let's stick there. Our time is coming to the end. But before I thank our participant, let me ask Martin Wied for the final presentation that he has for us.
Thank you. May I ask for the slides? It's coming. Okay. Well, this presentation was intended as a summary of everything what had been said, but these slides were prepared in advance, so it's a pretty strange situation. So I'm going to go through these slides and provide some comments, maybe related to something what has been said. First fact is that AI is definitely reshaping the entire science. So it's a natural process, and it's not about tools, but the question is how to do good science. And this is an important question. Even if we get rid of AI buzzword, what does it mean, good science? It's very hot, especially nowadays, topic. Maybe I will just go quickly through the titles and some conclusion remarks. The key question in trustworthiness is the question of reproducibility, and there is, from my point of view, there is not so much effort in reproducibility issues still, but the world is changing, and it is now in the lights. So, as we have mentioned, AI agents can read papers, rewrite the underlying code. They can help very much with improving. So AI will become a normal and standard part of the publishing process. Although there are some policies which try to avoid using AI tools, the trend is straightforward, pretty straightforward, using AI in all stages, in preparation of papers, in review process, also in evaluation of reviewers. It will be a good job for AI agents as well. What's happening here? Oh. This topic is slightly different to issues which were discussed here, but it's about LLM competencies. the question of correct reasoning of LLMs. There are recent papers which demonstrate that in some scientific areas the reliability and correctness of inference is not so high as we expect, and it is not changing so quickly. LLMs can produce nice looking papers, but this is not a question of real validity, which should be tested and evaluated maybe more carefully than in history. And this topic was not covered by us, AI in everyday research operations, because doing research or doing science is not only about doing experiments, performing experiments, writing papers. It's about administrative stuff, filling a grant proposal, form fields, and so on. And this is, of course, a big job, a big opportunity for AI tools on both sides, on the side of creators and also on the side of reviewers. But there is a big question how not to become overloaded on both sides. We can create simply project proposals, but what to do next? And some remarks and question. As I've said, I'm an optimist, tech optimist, and we can say that producing papers now, or the cost of producing, is going limitedly to zero. Yeah. You can ask LLMs to produce reasonable papers, and mostly you will obtain something not so bad. But how to exploit this? And this mass production of scientific result is also the opportunity to stand on the shoulders of AI produced results and on AI giants, we can say. And the question is how to exploit the explosion of the mass production of AI generated scientific content. And there will be no strict borderline between AI and human generated content. Yeah, but this will be the new shape of science. But the question still remains: what does it mean to produce good science? And that's all.
Thank you, Martin. Thanks for the wonderful summary. I also want to thank remaining participants in the discussion, Barbara Zitova and Jan Šedivý. And on my behalf, thank you for your attendance, thank you for your questions, and have a great rest of the day. Thank you.
Hello, everyone. We are 10 minutes late. We didn't start even. Okay, so 2 days ago, I was asked to moderate this session on robotics, open data, fair data, automation, and so on. So this session will bring another perspective on the continuum between data, automation, and real life production. And it will bring more, or I believe, because I didn't see the presentations, more practical angle to what can AI and big data bring to this. And we have 4 speakers. Actually, all of them are from this building, if I understand correctly. And I would call them researchers and R&D, or how should I call them? And they are will be touching topics like Industry 4.0, system optimization, system scheduling, robotics, object identification, human-machine interaction, and of course, data, AI, data, and so on. And I suggest that, and I will start by, okay, so there is a mess in my, sorry. I lost one of my papers, which is disaster, because I know nothing by heart. Okay, here it is. Sorry. So the first speaker is Tilman Beckhoff, actually from, as I said, from CIIRC, and he is expert in the field of Industry 4.0. I would actually say, from what I've seen, that it's probably even 5.0, 5.1, and so on and so on. Actually, he comes from Germany and was working in DFKI, even though I should not pronounce it this way, because KI is actually AI in German. And since 2020, he is at this institute, director of RICAIP, Center for Research Innovation Center for Advanced Industrial Productions. And he has he focuses on digital transformation. This is probably one of the main topics, but as I mentioned at the beginning, it comes all the way down to human-machine interaction research. And it is all about, as the name of the institute says, it's all about industry, linked to industry. That's why I said it should be more practical. Tilman, the stage is yours.
Thank you. So let me start with a few slides explaining where we are, because you're guests here at the RICAIP testbed Prague, and what we do and how we strive to do it, and how I think these topics, AI, data, and robotics and optimization all are linked together. So first of all, the RICAIP project that we are closing, let's see if this one actually works as advertised. Yes, it does. Good. The RICAIP, just one slide. Yep, thank you. So the RICAIP project is probably the largest EU project in this field of AI and Industry 4.0, where Industry 4.0 refers to the fourth industrial revolution, meaning the digitization and networking and all of the consequences that derive therefrom in industrial production. As a center, it's newly established. It's multi-site with another big site in Brno here in the Czech Republic, and partners in Germany in Saarbrücken and Kaiserslautern at DFKI and ZIMA, 2 different organizations joining this. And we're about industrial production control, remote activities, distributed production, and all of the topics that Industry 4.0 covers, like the dynamic rapid adaptation, lot size 1, and so on. And financial support is quite substantial from the Commission and also from the Czech government, building up the testbed that you can visit this afternoon. We started with these 3 partners, Prague, Brno, and Saarbrücken, with 2 organizations there. And have expanded this network to another node, the Smart Factory in Kaiserslautern of DFKI, partners at Fraunhofer in Dresden, at the IWU Institute, and also at the University of Ostrava. So this strives to build an ever larger network, including other European and international partners eventually. What you see here and can visit this evening, and I highly recommend this, is 2 levels plus some more rooms of facilities with lots of robots, but also production conveyor belts and all kinds of machinery, milling, 3D printing in particular, looking at all of these topics around robotics in teams with humans, in hybrid teams, the logistics, at least the intramural logistics, not trucks on the highway, but AGVs running around, and all of the computation that is associated with it. So this is not just mechanical engineering, this is a big part of it, but also electrical engineering, computer science, bringing all of this together. And it addresses a bit arbitrarily picked these 3 big trends that you see in all kinds of ways in Industry 4.0. An obvious one is optimization, which means resource efficient production and can include waste management, because ever more efficiency means circularity as a logical consequence. It also addresses the human issues. We have an aging workforce. We have the ability to be more inclusive, include people with different educations, different capabilities, bring people to tasks that they haven't done in a long time, even though they might be experts, they might not have the current experience. And that kind of human-machine interaction support is possible these days. And also the production processes become more complex. On the one hand, in the sense of never quicker product cycles, the need in some areas to have very highly individualized small batch products. On the other hand, because we can do it, and also because modeling things in Industry 4.0 includes the entire supply chain, all the way to China. That has always been the case, but once you are able to model it, you can do things about hiccups in the supply chain. So be more resilient by modeling your supply chain, by having early warning systems that tell you that there are dangers, and allow you to replan according to the current offerings on the markets, and eventually creating new such markets. And that drives our research in things like production processes, automation in general, energy management, of course, human-machine collaboration, and the use of AI in all of these processes. So for that, we've developed over the last 6 years a number of use cases and demonstrators covering all of the different aspects in concrete examples with industrial equipment. So this is a laboratory in a certain sense, but then again it's real in the sense that the actual hardware is exactly the same as on the industrial shop floor. Things like milling and simulation of milling, remote control, modeling of things in 3D worlds, recognition, autonomous inspection robots, which our partners in Brno, for example, are doing. And you'll see some of the examples if you participate in the visits this afternoon. To enter the aspects that AI in this environment has, a few examples of what role AI can have in advanced production. So one, of course, is the human interface. The large language models for spoken or natural language generation interaction in general is, of course, the obvious one, but then it's also intention recognition. Can a robot or the machinery in general identify what humans want to do and therefore support them or warn them not to do this and so on? And can we model users in a safe way, of course, but to understand where people need support and how we can make production safer, of higher quality, and so on. But AI classically is much more than just these large language models. People nowadays use AI synonymously with ChatGPT, and that is extremely misleading because it's a very old science, more than 60 years, and it covers things like image and video understanding, so object recognition, so that the robot knows what it sees and what's around it. Modeling the world in 3D derived from this for the purposes of simulation, planning, and so on. Enabling autonomous robots and vehicles in general. Then, of course, robotics is a very old and large field. Many tasks there that are not fully solved. Humanoid robots are simply the latest buzzword. That's what people can relate to immediately, where people understand how versatile they must be, because they're like humans and we can do many things. And specialized robots who do only that are less interesting in many ways. But then again, I would warn against using humanoid robots everywhere. A truly versatile robot might eventually look completely different, because humans have their limitations and maybe we can overcome them with something else. So you'll see a lot of use of humanoid robots that are not very interesting, I think, but an obvious first step. And then a lot of this is computer science, so vibe coding. Coding with support from AI is one way of integrating all of these systems, at least the support. But it's all about optimization eventually. Can we do things quicker, better, and more dynamically? For this, simulation is extremely helpful, another area. And then as a consequence of all this, data will come more and more and more into play. So people are forced to collect data. It's easier because everything's digitized, but machine learning needs vast amounts of data. But in particular in industrial production, that has challenges with IPR protection. Big companies will not let their data be assembled by companies like Meta and Amazon and so on. At least they should not, and most of them will not. And then it's an interesting question and challenge where the computation should take place. Should it take place in the US, in Europe, at a big cloud center, or on the edge right here? And we're doing experiments with these kind of things. As an institute and center, we're expanding and see ourselves as a part in a big CIIRC network on the scientific, national and international way, with a lot of collaboration with other partners in the Czech Republic, but also in Europe. And here's just an example, a map of the most important projects where the testbed is being used in. This covers most of Europe. And you can see, even with Germany as a partner there, that's quite small. The rest is a big market, and when you do anything, particularly in the Czech Republic, this very small dark blue dot there, always think bigger and think of all of Europe and the world, although that might be a challenge. And we're trying to do this and support that. So if you want to work with us, there are many projects that are happening at the testbed. For example, AI Matters down there, which is the testing and experimentation facility of Europe with many partners in other countries in Europe. And the local European Digital Innovation Hubs, the EDIHs, in Prague and in Brno, but also in Germany. And I think I've more than filled my 10 minutes, so thank you for your attention.
Okay, so do we have one very burning question? One? If not, then we'll move on. And there will be discussion at the end of this session. So I will introduce the second speaker. Can you give us... Yeah, ideally, yes. Yeah. And the second speaker is Zdeněk Hanzálek, full professor at CTU. And it's an expert in scheduling, computation and manufacturing processes. with a lot of experience from France and even industry, including Profibus Association or Porsche Engineering, just to mention few. He's former head of Industrial Informatics Department and has a lot of, as I already mentioned, his experience has a lot of collaboration with the high-tech industry. And today he will more speak about, as shown, about ROBOPROX, which is a project which, in my words, this is just my wording of what I found, the information supports agile development of robotics for complex and modular processes. So I hope I was not far from it, and just telling you that it should be with a respect to environment. So,
okay.
Stage
Thank you
yours.
very much for a very kind introduction. And now let me just mention a few words about ROBOPROX. ROBOPROX is a very large OP project, Johannes Amos Comenius on Accent Research. It includes 18 groups and 190 researchers, so I will not be able to speak about all of them because they are working on different problems from robotics, informatics, control systems, and material science. We have three partners, which is Technical University of Ostrava, Brno University Technology, and University of West Bohemia. Right? So the overall motive of the project is to advance industrial production, and as you know, it's not easy task, right? As is shown in this famous film. And Europe therefore had a very good idea in 90s that we will get rid of production because we will do just intellectual work so that we don't dirty our hands, and all of Vietnamese girls will make it for us. Okay, so to say. So now we have production in Southeast Asia, and we have lost contact with the development. And we are buying products from there, right? So the idea now is different. And what to do to get this production back? We think that we don't want to dirty our hands again, so all the robots will make it for us. So this is the overall idea. Unfortunately, in China, they buy every year 5 times more robots than whole Europe, but this is how it works. Okay. So the idea then is to go further and to make it better. As usually. So this device really doesn't work properly. I'm very sorry. And we want to use our knowledge in robotics, informatics, and optimization algorithms to make it better. Okay. So in fact, today society, or at least Western society, is used to have a very specific customized product to distinguish every individuum from another individuum. So if you buy, for example, shoes from Nike, you can customize them, have different colors, have different motifs, and so on. The same holds for cars. You can customize the interior of the car, choose different functionalities, and so on, which looks very good. And unfortunately, this is a nightmare for shop floor production, because every piece is different. It's not only about the information, but it's also about efficient use of production resources, right? So with that aspect of customization, it's very easy to have very low return on investment, and to have very sparsely used production resources, because one robot is waiting for another robot, because every piece is different, right? So what we can do, we can apply optimization algorithms, for example, for scheduling, floor planning, and try to handle that in the best way, because human can no more optimize it manually, because every second is different. There is no repetition in our let's say sequence of products. So let me give you a very easy example on what is our approach. So our approach stands on the shoulders of giants, which means we are applying, let's say, underlying concept and background theories, for example, like operational research, and modern tools like, for example, AI, to solve and formulate application problems, right? So not to reinvent the problems, but to see that this problem in fact is the problem that we solved 20 years ago because it has the same mathematical, let's say, nature. I think this is a little bit core of what is called technical cybernetics, that different physical systems have, for example, similar differential equations behind, okay? So I can illustrate it on the problem of, for example, circuit design, which is here on the left side, where you see that different components are assembled together in order to minimize the space that it takes on a chip. Similar problem arises when you are designing shop floor of your production facility, because you have different machines, you have communication, let's say, communication area to move the product as well as you move the data in a chip, right? And a little bit more abstract example is periodic scheduling. If you make a periodic schedule and you do some weird transformation, then it results in such boxes that are also assembled within space which is aimed to be minimized. So we have 3 examples, and the background theory is a packing algorithm which is trying to satisfy all the constraints, to minimize the area, and to increase, for example, to minimize also the connections between the connection paths between these devices or machines, okay? So this is, for example, one of the results, the paper on that we wrote with ST Microelectronics. So you have electronic components. Each component can be represented by a rectangle, and the part of this rectangle is also isolation area in order not to disturb other components. So if you have 2 components that don't disturb each other, for example, they are running on the same frequency, on the same voltage, then you can overlap them. If 2 disturb each other, then you cannot overlap them. Okay, so the problem is a little bit different than simple assembly of rectangles. And the overall idea is to minimize the area and also to minimize so-called interconnection, because subsequent routing algorithm, which then does the wiring, needs to have components that are to be connected as close as possible. Okay. So another example from the same area is that mentioned periodic scheduling. So some of the processes, for example, communication protocols or maintenance of the devices have periodic nature. So a task is performed every period, right? And the periods are different for different tasks. And then you can slice this Gantt chart into rows and flip some rows, and then you obtain a compact representation of each of these tasks, even if they have different periods, which again results in a packing of rectangles into the 2D area. Okay. Then you have to react also on what is happening in the real world, okay? And for example, as you might know, we have many Czech companies have troubles with energy and price of energy, especially those that have very demanding devices like heating, hardening, and so on, processes. So for example, steel makers or glass makers, or let's say, for example, Skoda Auto also does gearboxes that are hardened and so on. So then, and you have time of use prices that are varying every 15 minutes. And then the objective of scheduling is not only to produce and produce on time, but also to produce with the cheapest possible cost of energy, which is different every 15 minutes. Okay, so it may be efficient given the state diagram of your energy demanding machine to preheat, for example, the machine by night when the energy is cheaper, to keep it on that operational temperature, and then the process itself may start in the morning. Okay. Another problem is to have also not only specific algorithms, but to have also more generic solutions that may be applied to different problems. So one of such solvers might be, for example, integer linear programming, if you have ever heard about, or another quite modern and very well popular in AI is constraint programming. This is a way when you specify the constraints of your problem and then you formulate criterion function, right? So these solvers are quite quite complex algorithms that are performing the search in a search space, and the search space explored by splitting domains of variables into halves. So you can represent the search space by the tree, and we applied reinforcement learning to choose the best possible variables and the best possible places where the domain should be split. Okay. I don't know what is it. Okay. So and now I will mention two examples on what we are working now on. One time. So one of them is personalized drugs. So in order not to eat so many drugs where the real drug is just small percentage of it, we consider to have such pills with micropills, such capsules. And if you want to complement these capsules, then you can no longer use a classical sequential system where one machine is blocking the other, because you have maybe 50 different drugs, and in the capsule you just put five different micropills. Okay, so the idea is to use so-called Explanar. If I may ask you to run it, Explanar is like 2D system with magnetic levitation, which is enabling to move holders of these capsules, and there is much easier routing and avoidance of conflicts because you are working in two-dimensional area rather than in just a sequential space. Okay, so if I may ask you for the next one. Okay, so the idea here is to find packing, placement, scheduling, and routing problems. I think I will go further, and I will go to my last slide. So for logistics, for example, you might have seen technology which is called AutoStore, which is a two-dimensional space where robots are moving on the top. May I ask you for the video of AutoStore, the last video? And the robots are digging the boxes that are underneath in the vertical direction, and there are so-called pickers, people that are serving different orders and putting products into the boxes that then go to you as a customer. Okay, so this is a nightmare from the logistic point of view, because you have many products. Every order is different, and it's very difficult to handle it systematically. So this is a systematic solution. By the way, this technology is quite deployed also in Czech Republic. I think, for example, Rohlík or Alza and these companies are heavily using these tools. And we are designing solutions like, for example, how to sequence the orders so that you have the orders with a similar product side by side. For example, if somebody is ordering banana, and then if banana arrives to the picker, then the picker can service several orders rather than asking another product, and all the banana needs to go back and forth. Okay. So this is one of the problems we are solving. Another problem is where to place the products in the store, because it has chaotic system of storing. So the position of the product is changing in the time with respect to the future orders, so that the orders that are coming have the products that are closer to the dispatching part. Okay. So thank you very much for your attention. I apologize if I'm too late, but this device is broken. I think it doesn't work.
Yep. Oh. Thank you very. Can we? Yeah. Thank you very much. And I'm worried we do not have a time for a burning question. And the next speaker is Petr Kadera, already standing here, associate professor also in CIIRC CTU, Czech Technical University, with a PhD in bioinformatics and experience from Rockwell Automation. And he works on multi-agentic systems for robust distribution systems, and will, since 2016, is at CIIRC, head of the group of intelligent systems, again for industry. So as I said at the beginning, lot of practical examples, and he's using AI-based systems technologies to improve effectivity, for example, of production, but probably mentioning also others, and similar to what you've seen before, optimization of organization things and so on. The stage is yours.
Thank you for a nice intro. So, in my part, I would like to view the era of AI from various architectures, especially of the various training sources that are used for training the AI models. And my motivation is to promote a new project that's starting this Friday, Czech AI Factory, that's aiming in the third era. So the the first era I want to talk about is era, and Zdeněk was right, this device is broken. The first era is about simulations. So it's era when the AI models were trained against a system that was fully controllable. We were able to rewind the simulation again and again and gather the data from a system that we can fully control. The second, okay. The second era is about era of archive, about large data set. This is the era we are currently living. This is the system when the generalized knowledge is based on the scaled up amount of textual information that were used to train the large language models and enables to do complex tasks, as all of us know from our personal experience. And the last era we are aiming at with our Czech AI Factory, and we are already entering in various fields, is about the era of experience, about the AI that's directly connected to the real world, and the agents living in the AI world are able to stimulate the physical world to provide the data that are needed to understand the basic principles how the physical world works. So let's start with the first era, simulation. So we have heard about many successes when the AI-based players were able to beat in 1992 Begemon in Czech Vrchcáby, the first big success of neural networks-based artificial player of a game. Then in 2013 there was a lot of news about the system based on deep Q networks. They were able to play the Atari games. The Atari games we might remember from late 80s when we were enjoying the first contact with IT equipment. Again, it perhaps yeah, this is so yeah, the second era, it's what we know from the large language models. All available knowledge is gathered, and there is one big disadvantage. It's the system works just on a snapshot of the knowledge, so there is like a knowledge cutoff. So the system doesn't evolve with the knowledge. We need to train new models again and again, and the knowledge is based just on what the humans describe. So the interface between the physical world and the digital world is based on the conceptualization that someone describes. So we aren't able to find new principles that weren't described in the text. So here we can see the development of the system starting in 2018 with system GPT-1 dealing with 170 million parameters. Today we are in order of magnitude of hundreds of billions parameters, and the system is still growing. But like since all the available data were actually used for this system, there isn't expect any significant qualitative improvements in this type of system. And let's move to the third era, the embodied interaction, the connection of the AI directly to the physical world. So this era started in early 20s, taking data coming from various robotic systems. Google was very active in research in this field, and currently the most significant outcomes are seen in the autonomous driving system, a well-known startup Waymo that builds their solutions and their end-to-end models, large models, based on the huge amount of already gathered data, but also on the data that are coming from the cars that are actually doing their test drives, and proactively identifying the problematic situations that are needed to cover completely the state space that's needed to develop a reliable system. So, and now how the Czech AI Factory enters this field. So what the Czech AI Factory is the Czech node in the Euro HPC network of high-performance computing centers. It will be open May 1st this year, so on Friday, and it has two basic pillars. The first is the new supercomputer that will be assembled and operated in Ostrava, Carolina computer, and the second pillar is the AI Factory Service Hub, which collects the know-how, provides the education not only to students but also to the practitioners from the industry, and also provides the basic components that can be then used to build services to specific users. So we are aiming at 6 sectors. The first nature is the mobility and autonomy, autonomous cars, autonomous robots, which overlaps with the second application area, industry and robotics, but also we are aiming at the sustainable energy, smart grids, renewable energies that are dependent on accurate forecasts of weather. Also important pillar is health and life sciences, development of new drugs, directly connecting the AI with laboratories that are used to generate data based on the new molecules designed by the AI system, cybersecurity, and also public administration. So the new opportunities that are brought by this connection of the digital and analog world also bring some difficult problem that needs to be overlapped. So it's the sample efficiency. So when we are collecting the data from interaction with the real world, we need either to have much longer time to collect the data, or many more sources of this data comparing to training the system on already available data set. Also, it's not that easy to define the reward, what's actually good, which strategy applied in real world is useful. Of course, comparing to era 1, when we were exploring various strategies, having the simulator in the loop, it's more dangerous to having real systems involved. So there are some safety concerns, whether we can harm someone with having the system doing the exploration part to openly. It's also difficult to evaluate how efficient the whole training loop is, and also the long horizon consequences are something that is a bit difficult to explain in a way that complies with our expectations. So I would like to invite you to stay tuned on the news coming from the Czech factory, and yeah, let's see where the new shift in AI will bring us.
Okay. Thank you. Thank you very much. Okay, so I'm worried that we do not have time for the one question. And the last speaker is Vladimír Petrík, again from CIIRC, an expert in robot perception and manipulation. The very nice information I learned about the 6D object pose estimation. I know 3D, 4D, I can imagine 5D, so maybe we learn something from about 6D. Learning from videos, that's wonderful topic actually. I know, I was aware about Vladimír, and physics-aware control of of systems. Experience from France, Finland. Simply expert for our session. The stage is yours.
Thank you for a nice introduction. And today I will talk about ELLIOT project, which is EU initiative to create AI models in Europe. So first, small motivation. We all are using language models, LLMs. I know programmers I know all use Claude Code to create programs, and LLMs can create nice text nowadays. We also have nice vision language models, so models now can understand images as well. Here is an example 2 years ago, from 2 years ago, that GPT-4 was able to take image as an input, text query, and could reason about what would happen if the strings are cut in the image, and produce the text as the output. But the world around us is not only about the text and images. And that's the reason we want to build another model which can include additional modalities. As an example is a robot proprioception, which measures where robot is in the space, or the depth measurements, etc. So ELLIOT is designed to actually develop this new next generation of open multimodal generalized models. So ELLIOT is a European project, quite a big one, which is supposed to advance large AI models, and it's funded by 25 million euros and gathered together 34 organizations in Europe. It's from the academic groups, industry and SMEs, but also from HPC providers, because big models require big compute. And the objectives of ELLIOT is to create a family of foundation models which are strong and have a robust generalization, so they can work even on data they haven't seen during training. On top of that, they will support multimodalities to work with robotic inputs or 3D models or code, but also should support long horizon reasoning. So being able to watch YouTube video and reason about that, or to watch climate changes and monitor that. On top of that, everything will be open. So the collected data should be open, but also the pipelines, so that the research is reproducible. A good question is why we need another foundation models. We already have GPT, Gemini, Claude, or DeepSeek and Qwen. They are very good models, but none of them was built in Europe. So they were built on or trained on internet data, but we don't know on which data. Some of them are even distilled from another models, so it's hard to reproduce anymore. But nowadays in Europe, we have enough compute. We have Jupyter, Lumi, so we can train our own models and be producer of models, not just the consumers. On top of that, most of the models I mentioned are closed sourced. ELLIOT will address that and have everything open. But how to achieve it? And in ELLIOT, we actually want to attack whole cycle of the model development, from data to large-scale training to fine-tuning methods, and then to evaluation and deployment on application domains. And all of that will be in several cycles, and I will look at a few of these points in details. So first, for training models, we need data. And as I said, current models use internet data, but without respecting license, or often without respecting licenses. ELLIOTs want to change that. We want to create a clean common crawl where we catalog licensings and copyrights, but also address ethical issues. If there is a human face on the video, we should have a flag in the data that shows that there is a human. And based on that, we can create different models that respect European values. On top of that, we will generate some data, mostly to support additional modalities which are underrepresented on the internet. And this could be Gen AI or simulations. And of course, supporting new modalities. Once we have a data, we will do massive pre-training. That requires thousands of GPUs, so we need AI factories. But also, we need to understand which architectures are good and which are not. And for that, in ELLIOT, we are studying scaling laws. So to see how model performance improves if we add more data or more compute. So we can do knowledgeable guess about what to do next. Then we are developing advanced fine-tuning methods, for example, to fine-tune from human feedback, so that the model can learn what human says and adapt to that. And all that is coming with in development cycles. ELLIOT will release its models every 6 months, starting from end of this year. And all models will be evaluated with a new evaluation platform, which is developed in ELLIOT, so that it provides early feedback to the people who do training. Top of that, we will deploy that to several domains. And in ELLIOT, there are 6 different application domains, ranging from media, checking facts in live shows, or Earth observation, as well as computer engineering, code generation, finding the security issues in generated code, but also patching them. And I will focus mostly on robot perception, is where my knowledge is. And for robot perception, we need data as well. Here is an example of the biggest data set, or one of the biggest data sets available in the internet, where several institutions jointly collected 76,000 episodes of robot, where human tell a robot to do something. And on top of that, we can train model, or at least fine-tune it. And as was mentioned, now VLAs are the approach to do that. So we can take internet pre-trained VLM, which could be ELLIOT in the near future, and then train a small action head on top of that, which predicts the robotic actions. And if you do that, we can see nice performance. Those are those are videos downloaded from internet. A robot perform very cool tasks. Can do laundry or prepare an apple. All of that was trained on the collected data. So humans were showing demonstration to robot what to do, and then we fine-tune a model to replicate that motion. And these videos suggest that robotics is solved nowadays. So we tried it in our lab on much simpler tasks, where we ask model to rotate the marker or open the drawer during night, because our students work during night, and it fails. So even a simple tasks are not solvable yet, and it was recorded during night. That's important, because then we observe that that's the problem of these models nowadays. They are trained on the data which are collecting during the day. But to actually measure that and have some proofs, we designed a relatively invalidated benchmark where we analyze these distribution shifts, which allow us to identify when the models work and when not. So we define several disturbances, changing the lights, changing the textual instructions. Instead of pick the banana, we say pick the yellow object. And the model should understand this natural language. And often does, often don't. And we observe that under this perturbation, the models are not very good. So a 60% success rate. So that's not impressive compared to the videos that we show. So the robotics is still alive. We need better models. And we need data. After we analyze what is not working, we can collect new data. We design a device which can control the robot more naturally than using VR. And we collect the data for actually performing tasks that were underrepresented in this internet data. This example of pouring, a robot is repeating what a human is commanding with the device. And after we have data, we can fine-tune. So in ELLIOT, we actually develop a method to fine-tune these models. And you can see on the left, state-of-the-art model, Pi05, which is performing the task, tries to achieve that, but fails at the end. And our fine-tuning, which requires only about 100 episodes, so it's 2 hours of data collection to actually solve the task. So these foundation models are important, but we need to fine-tune them for the task we actually want them to perform. But data collections is difficult, costly, so we are also looking at the alternatives, how to collect the data from internet. And here comes 6D pose estimations, where we are estimating 3D position and 3D orientation of the object in the internet video. And then we can transfer that to simulated robot or to real robot and augment our existing data even more. And that's all for me. Thank you very much.
Thank you very much. And yeah, I was happy to see the 6D. Okay, we have, Michal, I added the 10 minutes from coffee break to my session. We have the time for a few questions. I will be opening the stage in a second. After asking one question, is there something missing? Because all your presentations looked, except for the last one probably, everything was so perfect. Is there something what you would, except of money and time, appreciate to have to improve your system?
Okay, so I will start. We need data.
Yeah, we need the connectors to the physical world, the use cases, the real world scenarios to work on, and yeah, and the partners from the industry, the practitioners. Yeah.
Yes, definitely. We also need good inspiration from industry, I think, to solve specific problems. And we need more intelligent solutions on our side as well to develop things that can scale, that are able to solve, let's say, large problems, because today's problems typically are very large.
Yeah, and I think the thing about data is we need more data. that needs to be said again, because it's not binary. It's a spectrum, and you can never have enough.
Okay, thank you very much. And I'm very happy that you mentioned that you need more data, you need more use cases. And this is exactly what we will speak about. So a little marketing for my session, because this is just a stolen session, which will be after the lunch. So please don't take after lunch nap, come to the session and listen how to get more data for these projects. Okay, are there questions from the audience? Immediate questions.
Interesting, more data, right? This reminds me famous Borges story. I don't know whether you familiar with it. It's about building a map of the world, and the thing is that this map is becoming bigger and bigger, and eventually it reaches the size of the globe. So, I think you understand the metaphor where I am going. My question is whether you think in longer term ideas, we are replacing step-by-step individual human activities, including physical ones, but also now cognitive mental ones, right? So a lot of new questions are arising. If we replace workers, what will happen if work, a lot of work disappears? What should we do then? So that's my question. Whether I understand you have to focus on short-term perspective, but I think it's your responsibility also to think in longer terms concepts. And that's my question. Thank you.
We'll start this. It's a very general, if I may, a very general question about automation. So the answer is an old one, because the question is old. If you build weaving machines, you don't eliminate the workers. They're still humans. They're still alive. Their jobs have gone, and they will need to look for another one. And that is the real question. So if the jobs change, and all our jobs are changing over the years ever faster, how do we support that change in jobs? So I do not believe that we eliminate workers. We do indeed eliminate specific jobs, and other ones will appear. And I think it's our responsibility to think about what those are. And as an example, take software engineering. Vibe coding promises to make everyone a programmer. It turns out that's not true yet. So what really is the interesting question then is how can we build new workplaces, new desktops, new software development environments where people are more productive, but we know that we still need people in the loop, although for different tasks. And how can we support these different tasks? So any kind of human-machine interaction that supports telling people what the machinery is doing and where questions are arising and to be solved by humans, that is part of the answer, I think.
Yes, I like your example with a map of the world because it shows that everything has some limits, okay? Let's say physical limits for simplicity. For example, machine learning is demanding a lot of energy. We need large data centers consuming a lot of electricity, and then it obviously has some limits, right? So maybe we can formulate it in a price of the energy, but also in, let's say, ecological limits of the earth, right? So there are obviously limits, and we have to deal with that. Also, customization has limits because our past generations lived with products that were not customized, and they survived. But we need to have every path so different today. I have seen, for example, on statistics that in Germany, for this, let's say, delivery services, in each order you have in average 1.6 items. So typically you are ordering just one item, and there is a parcel reaching you with just one item, right? So does it make really sense? It also pays on the limits of, let's say, transportation, fuel consumption, and I don't know, the throughput of our streets. So there are obviously limits, and we have to deal with that, right? This is our responsibility.
Yeah, I think this is like a task for the. It's a multidisciplinary topic, and it's not just about technology. Remember, I think it was Kodak when they discovered the new potential of digital photography, and they realized what would happen with their business of creating the stuff for the analog camera. So and where is Kodak now? So like we can't stop the progress. We need to stimulate the question what's actually what are the basic fundamentals of a democratic society, whether the correlation between the first industrial revolution which increased the value of the motoric and the capability of reasoning and the soft motoric of hands actually distributed equally the wealth among people, and it actually brought the wave of the democratic democratic changes. So whether it is something that can be harmed by current centralization of the capability to reason and produce something. Yeah, there are many questions. I mean, like it's like a red queen, or like the only thing is like to continue in the progress, identify more stuff. Like there is no chance to like artificially stop the technology and stop the research, and yeah. But I can see many dystopic scenarios in front of us, and yeah, we need to open that.
So everything was said already, but I agree AI will change many fields, but it's still a tool, and it will remain a tool. And for me, AI will not take your job. It will be taken by someone who use AI for its benefits.
Okay, more questions?
Thank you very much. Tilman, in your talk, you tangentially mentioned the connection or the relation between the edge computing versus localized high-performance computing in the context of your talk. Would you care to elaborate a little bit more on this?
Just a little bit. The question that arises is what kind of compute is needed for specific tasks, and one additional constraint is safety in your processes. Are you happy with a connection to a remote compute center? Is that line safe enough, and is it quick enough, of course? So ideally you can do things on your want to do things on your premises, but maybe you can't because the compute task is too big. But it's worthwhile exploring to take as many things to the local level as possible. And a lot of the high compute is not needed for inferencing per se. It's done by the big AI companies in compute centers because they're serving millions of people. But if you're serving just one machine, you can, in the very near future, do most of the compute locally, and then you should. So this is what's driving appropriate edge compute nodes with a failover connection to the big cloud centers, of course. So this is something that is what people are experimenting on.
Do we have more questions? Everyone wants a lunch. So, okay, thank you.
Thank you. I would like to ask, actually, hearing about ELLIOT and similar solutions, do you think that there is some viable option how to really cope with the developments of the business solutions, and which are actually provided by the big companies? So what is the role of academia in that? If it's feasible to cope with the developments, or what will be the like real future of such academically developed models?
So for me, no, we cannot compete with them on the task they choose to progress. So they are training models, they're providing LLM for us. That's not our job. We should see the scaling laws. We should see what works, what not. They can then adopt that and improve their models based on our findings. But on top of that, there are a lot of applications. We need to develop methods how to fine-tune these big models. And that happened in Vision. In Vision, no one is training foundation models from the scratch anymore. They're all using Dino or similar models and fine-tune them for the specific applications. So that's my answer.
Okay, more questions still? Yeah.
In the Czech AI Factory presentation, it was mentioned that there would be AI training in academia. Is that something that would be available to academic institutions or public, or just to people that would be interested in collaboration? How would that work?
Yeah, and the one part of this academy, it will be a series of summer schools first happening this September already, and in this building there will be like one dedicated space, dedicated room, which will allow organization of individual lectures and talks focused on specific topics that will be currently required by the possible audience. So there will be like a dedicated space, and all researchers involved in the project has a duty to contribute to it. So we want to provide like a broad overview of topics that are potentially interesting for the external audience.
We have last 5-7 minutes, and some of you mentioned use cases, that's what you would like to get, but you were largely focusing on industry. Can society or even primary and secondary education, the future generation, bring you the use cases?
Yeah, if I may start, it's not something specific for the industry, but also like the feedback of an audience. Like currently we are working on a project when we are using AI to optimize communication with customers, for instance. So the measuring the feedback and proposing new communication strategies, adjusting tone of voice to the specific channels and the audience we are communicating with is something that's a perfect use case when which brings the real world in the loop. And the real world doesn't mean that it's a robot doing some manipulation task or an autonomous car driving in a city, but it can be also like a human society and yeah, anything that can bring like real insight.
What comes to my mind is, for example, a humanoid robot. One of the teams in our project is studying that, Dr. Hoffman at Charles Square, and this is a very attractive topic. It will not be only related to industrial production. Of course, it will be in families, maybe in healthcare, maybe in elderly people treatment. So humanoid robots, for example, don't forget about them.
I'm not sure I fully understand the question. My interpretation is, can we learn something from the research that we are doing on industrial production to be used elsewhere? Right?
Yeah, of course, that's one interpretation, and it's not bad because it's an interpretation. Another would be if future generation, really young people in primary and secondary education, can bring some use cases for you which could be very inspirative and actually bring some novelty in your work.
Okay, so in that direction, anything that happens within households, where something creative maybe even, but especially something that's labeled work is being done, has certain similarities to the environment in industrial production in the future. So you need a full understanding of the environment, a digital understanding, and you need to understand the human's intentions and the external constraints. In the industrial world, that is the products to be produced or to be designed and then produced. And in a household, those constraints come from multiple sources. Mom wanting that place to be cleaned, or external things, and the interaction and the modeling, because it all strives on having descriptions of what's happening in a way that are exchangeable and understandable. Those have strong similarities. So I think a big area of robotics is going to be household robotics, beyond just the vacuum cleaners and window cleaners that we already have. You'll see a big development there, and there are lots of similarities there that also can explain how the workplace of the future is going to look, which we really don't know. That's what we're working on.
Comes to my mind maybe that in design in general can be better supported by some tools that understand the context and so on, right? So, for example, I have just an example from civil engineering. When you are designing your house, then there are some rules that needs to be obeyed. For example, the kitchen and the toilet needs to be close to the outlet, right? And then you have some freedom in which you can redesign how big which room will be, but there is also minimum size of the room. There are some doors and so on that need to be there, some windows, and they have some rules that you do not know as a non-expert, but experts can encode it into your design tools, and then you can use the freedom to within these boundaries to make it. Okay, so today's experts are disgusted when the users still need some changes, right? And the users, they don't know all the rules, so to say, if you speak to architects, for example, right? So this is maybe the space, but it was just an example of a design. We are designing many things, kids are designing also many things, so this is maybe the space.
I've only added, so we need tasks that are worth solving. So it doesn't matter from which generation it comes. If it's worth solving, that we should be solving that with AI and robotics.
Okay, thank very much, everyone. We almost skipped my question of I was actually trying to guide you a little bit towards education assistance or these kind of things, but doesn't matter. Next time. In this session, we've been educated, or our knowledge was expanded by Petr Kaderas, Zdeněk Hanzálek, Tilman Becker, and Vladimír Petrík. And I'm Marek Cebeca. I didn't introduce myself at the beginning. CIIRC Institute, and see you after lunch. Can we continue, please? I'll ask you to take your seats. Okay, I'll ask you to take your seats because we have a fantastic program in the afternoon. Not only the session which comes, but also the one after, which will be maybe late, everyone tired, but the topic is hot, so I suggest you to keep some energy for the last session as well. Marketing as always. Don't worry, I will not moderate the last session. I'm sorry that you see me again after the lunch. It's not hallucination of AI, it's me, yes. Yes, real Marek. Okay, so we started with a session kind of philosophically to wake up in the morning, of course. It's a nice start. Then we had some reality. There was a lot of industry influence and so on. I was trying to push it off the industry, not always successfully. And now we are coming to the research, or better saying science. And because the previous speakers, when I asked them what they need, they said use cases, of course, that's very important. And they pretty much everyone said data. Where this data come from and how to get this data. And that's the topic of this session, which will have a form of two talks from speakers which are coming from abroad. I was very lucky to convince my colleagues, I would like to say friends these days. And we will start with Maciej Harancik from D.A.R Institute in Madrid, and he will tell you something from his experience about data. Maciej, come in. we will start with you. Do we have the presentation ready? Oh, great. So, the stage is yours.
Okay. Good afternoon, everyone. Thank you, Marek, for the invitation and opportunity to present our work. So I will change gear a little bit because I will present a use case. I'm a chemist, and a few years ago, I guess I was convinced that we are at the era of democratization of robotics, and that I can apply this methodology to help help with design of new materials. So really, I will just tell you a story of what are we doing with robots, maybe highlight few issues that we have, and focus on specific case. And I will be very happy to engage in conversation later on. So I'm working in D.A.R Materials Institute. We are in the yes. I just want to show the photo. So we are small research institutes. We have very good science, but we are only 200 people, less than 20 research groups. So my group is basically 10 graduate students and maybe 2 postdocs. So we don't have technicians, we don't have robotics experts. We are really domain scientists, mostly materials engineers, chemists, and physicists. So why do we need why we start thinking about robotics in materials discovery? So what is materials discovery? So when you think about materials, we look always for better materials, more efficient, cheaper, to replace harmful substances and so on. So the traditional approach is this Edisonian approach, that we have to do lots of experiments to find the right material. And in the first approximation, we want to basically use smarter techniques based on machine learning to build a model that will help us decide what properties the material has before we do experiment. This is what we call the structure property or composition processing property relationship. So this is this approach involving machine learning I employed all my career, but I started as a computational chemist. So initially in my career, I was basically building computational workflow using molecular simulations and building material informatics to employ machine learning to predict properties of materials. And then around 10 years ago, I moved from the US to Spain and then to smaller institute, and we are more exposed to real experimental data, so working with industrial partners and so on. So we started using experimental data to build those composition property models, and we're quite successful. So for example, in the case of collaboration with a company working with natural porous materials, we actually designed few materials with AI that are already in the market. We got very excited. And the problem is, I would like to do more of it after the project finish. And then you realize that when you work with new materials, where is the data? And really, the problem is whoever has the data has the power to use AI in this application. So around we are not lucky with COVID, but we are lucky with post-COVID stimulus funds that allow me to start. Basically, we bought the first robot. So in 21, and I negotiated again. My background is in computational science, so I just had an office. I didn't have a lab, so I negotiated a small space in a corridor. We bought the first robot. And then we start, building, testing, and teaching the robot to do experiments. And then 2 years ago, we secured a new lab, and last year we moved. So now we have a proper laboratory where we basically teach robots to do material science experiments. So this work fits in basically it's a global trend of using automation to accelerate materials and chemicals research. So the concept is called the Material Acceleration Platform of Self-Driving Lab. And the idea is here that we combine AI with automation in kind of closed loop system, that once we decide on what is the objective application of a material required property, we have this closed loop system where AI suggests what experiments to make, robot make the experiments, characterize material, and we feed the data back to AI. In most of those approaches, we apply Bayesian optimization that gives us lots of interesting
functionalities, design of experiments allowing us to sample our configuration space. It has the surrogate model that you know, is a regression model that tell us basically allows us to make predictions from data. The framework allows for active learning, uncertainty quantification, and so on. So practically all the automated labs use this framework. So this revolution in the automation lab is, of course, more researchers working this field, although not that many because it's still a very expensive approach. But a good highlight is this work from Andy Cooper group from Liverpool, and there was a paper was 2020, so 6-7 years ago. They show an application of this automated robochemist to look for materials for photocatalysis. What is interesting is, of course, it was a successful story. They found few interesting materials, but what is really interesting is the comment somewhere in the text that they believe that, you don't see it, I will read it for you, that this automated system allows to accelerate discovery 1,000 times, which is 3 orders of magnitude. It's really amazing. Now, from my practice, I have to comment here that this acceleration rate really depends on what is your baseline. And the baseline is comparing to, so in this case, if you talk to Andy Cooper, he will tell you the robots did in 8 days what a PhD student can do in 8 years, in 4 years, sorry, in terms of number of experiments. But in practice is that in a graduate student research is lots of inefficiency. So for example, in my lab, I will mention in a second, but we have a step that before we process material, we have to dry it, which means we have to put the material in the oven for 24 hours. Now, what happens is a student comes on Monday, put the material to the oven, and can do experiment on Tuesday. So then you have only Tuesday to Friday window where you can process a material, but you can buy 15 euros timer and set a timer to turn on the oven on Sunday to dry the material, and you will gain for 15 euros you and a small a timer for introducing automation, you gain 25% of productivity. So I think as a community we have to really discuss how we measure this acceleration rate, because there could be lots of overselling there. Anyway, this automation, the methodology is, of course, it's not only one lab. It's you see just a couple last 2 years. All the if you look at the state-of-the-art research in mostly related with energy rating materials, because this is where mostly funding is right now. It's published, Science, Nature. All those leading studies incorporate automation. And there is another trend that is important. Is now. There's few automated labs that are available. They start thinking how they can collaborate to actually cover more complicated properties, or more complicated material cases. Often it's, in one lab you can synthesize the material, then to integrate it with a device or perform advanced testing, you need another lab. So there is this concept of the distributed laboratories that they need the infrastructure to talk to each other and perform material optimization. And there is another concept that I would mention. It's a cloud laboratories. And in this case, it's basically like we have a software as a service. We have opportunity to have laboratory as a service, where we put all the expensive equipment in one place and we can communicate it just through internet and perform experiments remotely. I mentioned this also as an introduction to the following lecture, where we more focus on understanding the data. But this is an illustration why we need to think about the data and how we connect those systems, because we need to integrate them. Okay, going back to my work. So I'm more my work focus on polymer nanocomposites and the application. So basically, you can look at them as plastics and advanced plastics. And there are, in this case, we have quite a large range of polymers that are used as a base material for plastic, and then we can modify them using different additives. And this is, very important market. It's estimated 500 billion annually for plastics, and they are used for almost every aspect of our life. And the question is, how we can accelerate design of those new formulations for different applications. And
why we need to design? We need more efficient materials. Sometimes we want to replace synthetic polymers with the bio-based now to make basically to have greener technologies. We can also use those nanocomposite materials as carriers for advanced functional materials. And then it's the whole library of different those additive materials that we can introduce. So the most important way we produce plastics is what is called melt compounding. And in this case, we take this thermoplastic material, we increase temperature, we melt it, and then we can, once it's in liquid form, we can mix it using extrusion, and then we can manufacture parts. So, for example, one application why we need it is one of projects that we have is designing material for electric vehicle. And again, this is not a design of a battery, it is a design of a battery casing. So in the electric car, you usually have this box where batteries are. And currently, this box is made of metal because the norm says that basically box has to be rigid, has to have structure properties, but it also needs to be fire safe. The typical test is this UL 2566 or 56, where basically a material has to withstand a flame of 1,200 degrees for 6 minutes. So what we try to do is design a plastic-based materials that will be much lighter, but will still sustain this material. So this is just an example, although I will not focus on this application. So how we design a plastic. So usually we start with material. So when you buy plastic in a large scale, you buy it typically as a pellets. Sometimes pellets are already pre-mixed with additives. This is what we call the master batches. Then we mix right composition that we want to investigate. Then we use extrusion, twin screw extrusion, to mix together and also melt together and mix. Then we usually produce filament. We cut it into pellets. And then from those pellets of new composition, we can either use 3D printing or we can use injection molding to prepare a specimen for testing. And then we can do different characterization, mechanical, thermal, degradation studies. And once we collect the data, we feed it to AI, like Bayesian optimization, and it tells us what new composition to study. And we have closed loop until we identify the right properties. So how we automate this workflow in the lab? So first we buy some robots, collaborative robots. They are very simple because basically they move. We send to the robot coordinates and they just move. So we have to implement all the computer vision. So in our lab we started with the solution based on the augmented reality, ARUCO code, and basically important instruments or positions in our lab are marked, and there is a camera on the robot, and then we can, with simple math, we can basically correlate positions of the ARUCO with respect to the camera and the gripper on the robot, and then we can have simple function. Like here we have the. Sorry, that was a simple. Video. I will show you another video. So here's another problem we have, that the robot needs to detect our specimen. So working with, for example, mechanical properties of materials, we use this kind of specimen, which is like a pencil size, and we have to detect it. And here, fortunately, there are tools that are already available, like this YOLO library that can be. It's a AI model that can be easily retrained to detect shapes and objects that are present in our lab, and then with just retraining of this network, we can detect our specimen, and then the robot can grab it. And in this case, we process. We need to, after injection molding, we need to cut this spare piece that is basically part of the mold. And we can integrate it with the robot. So here's an example. The piece is coming from injector. The robot detects the specimen, and then we just verify that the gripping is correct. Then we put it to kind of 3D printed aligner, and then we just cut it with ultrasonic knife. So now we have a sample ready for testing, and we can put it on a tray that goes to a testing station. Okay. So one problem with working with plastic is our machinery to generate specimen, to extrusion. Those are large machines. So our experiment don't fit in one table. So we have to think about how we can move samples between different stations. And then again, as a small lab, our funding is limited. So we decided to use cheap mobile robots. Those are kind of research and development robots. This particular one that we use for testing is based on the Roomba vacuum cleaner. So it's around 3,000 euros, but it has a LiDAR camera, and we use it, basically teach the robot recognize our lab, and we can perform basically movement of sample between stations. So sometimes when we want to do automation, we cannot buy equipment because equipment doesn't exist, and then we are very happy to have the community of researchers building open source machinery. In this case, we built a basically multi-material pellet dispenser that allows us to, just with a simple computer code, we can make a mix of pellets of a composition we want to study, and this will be integrated in a closed loop of our automated lab. And here is the whole extrusion station. So here we have our multi-pellet dispenser, and they can basically, with computer code, generate any composition, goes to a balance, then the robot can feed it into extruder, it's melted together, cool down in water bath, and then we can cut it in pelletizer, and then we have also custom collector. This is like an articulated tube. So as we start in a continuous manner, introduce different compositions to the material, then we can collect them into different containers. So we are moving towards the continuous process. So here is the video, how it works. And again, this is a kind of project that was done by some, we hosted summer students from aerospace engineering, industrial engineering, and so on. So those are kind of summer projects that later on took few more months to polish them out. So we have a mixture here, melted together to produce filament. And then we go to pelletizer to cut those pellets, and then we collect them into basically different compositions, go to different containers. And in the next station, we can do injection molding to produce sample, and then finally we can perform mechanical testing. So here we have the station, we have a collaborative robot, and here we have a CIIRC impact test. It measures basic energy required to break a sample, and then we have universal testing machine with tensile tests. So here is just a video, and we can leave this trace transported by the small robot, and if we produce more samples, we can just leave it overnight. And here we perform the breaking CIIRC experiment where the pendulum breaks sample, and then we measure the energy of breaking. And on the same station, so now the robot just restarts the pendulum. And this is an example of analog machine that we have to digitalize it, so put a camera on this dial to read it and then interpret it. Okay, and this is ongoing work. So right now, for example, we are expanding, it's building another station that will be doing fire testing of materials. We use similar specimen. And in this station, we basically can, we have our trays with samples. The robot can place it in a holder here, and then the burner moves with flame, and basically we start observing what happens to a sample. We record everything on a camera. So this is basically what we can develop ourselves. Some fabrication and combining this, camera, Arduino microcontrollers, and robots. Okay, so what can we do with all those different stations? So our first example, we look at optimization of 3D printing parameters. So we set up, this experiment was one of the earliest we've done. So everything still fitted in one table with one robot. We have 3D printers. We have a station that can analyze the samples that we 3D print, and we can perform mechanical testing here. So here in just this illustration, we focus on how we optimize 3D printing parameters to get the best results. And we have the two functions that can measure the quality. One is looking at the
basically the mass of the sample. So in a ideally printed, you have normal extrusion, and basically the difference between the weight of your sample and the weight based on the density of the material and the computer model should be 0, right? If the print is correct. So if you over extrusion, the mass will be bigger. Under extrusion, the mass will be lower. So we can measure this delta W, or we can use computer vision to analyze surface roughness. And then in this automated system where we do print and tests facilitated by a robot, and we can optimize 3D printing parameters to, in this case, to approach this delta W equal to 0. Here's another example of project where we look at degradation studies. So here we have many compositions, samples, and the robot periodically every 6 hours takes a sample, looks at, for example, if it absorbs water, and sends it for mechanical testing. Here's another example where we do multi-objective optimization or composition of material. In this case, we have one fire property, one mechanical property, and as we perform more experiments, we monitor. So there are 2 different properties. So we look at the Pareto front, and we see that as we add more data, we have more refined Pareto front. So it's an example of an application. Okay, so I will be coming towards the end of this highlight. So here's a real question. So I show you with automation we can do more experiments. So the cost of data is getting cheaper. The real question is, what are we learning? And I've been thinking about it a lot, because for me this journey into robotics was also a change from being a computational chemist into being a really experimental chemist. Although now I have more students and I rarely do the work myself, but I spend a lot of time in the lab. And I'm thinking, what is the biggest shock from coming from a computational field, which is also the AI field? And it's really how noisy, what is experimental noise, and where is it coming from? And this noise is everywhere. So I just want to highlight a few examples. Examples with 3D printing. So we try to optimize what are the parameters at which we should print a new material. And what we see that we have various printers. They are from the same manufacturer, the same model, but they have slightly different optimum for printing. For a computational guy, this is a shock. If you have the same machine, it needs to produce the data the same way. It doesn't. Another example, here is we monitor a weight of the sample in a degradation study. So it's absorbing the water. So the weight goes up. But as you see, every 24 hours, the noise is much larger. What's going on? And this is basically during the day. There's so much movement in the lab, it affects the measurement. And then you have a weekend, so it's less noisy. So you see it. There is another example where we look at mechanical properties in this degradation test. And you see that something happens on the day 1.5. You have a very large spread. What is going on? And we still don't know, although we suspect what's going on, is that once this sample starts to degrade, basically the weakest part degrades, and the properties is given by the part that is less degraded, the crystalline part. And in a polymer, the crystallinity of polymer will depend on basically on the processing conditions. And what we look at with differential scanning calorimetry, when we produce a series of samples, the same specimen, and we analyze property of the first, the 100 and the 200 sample that was produced in injection molding, they have different properties. And why is that? Because as you keep injecting, the mold temperature changes, and we don't have a full control over it. So basically, we think we have the same material, we have the same machine, we have the same day, the same set of experiments. We are producing different materials, and basically now we have a better idea, but initially we didn't know. And then we can see it in the DSC measurement, but then it can also be visible in other experiments. So just to leave this something for the next talk where we discussing this. The point is that without semantics, without this additional information, understanding of the data, with automation we're just producing more messy data. And we have to think further than what traditional as chemists or material scientists think, that they think that the material is just a composition, or the material is just a synthesis recipe that is in the literature. It's not enough. What we need to do in those automated labs, we need to basically data log everything. Exact conditions, procedures, timings. We need to use Internet of Things to control the room temperature, all the parameters that are in the environment. We need to store this data. And then once we stored all those different data streams, of course, if you want to share it and we want to use it in bigger projects, we need proper annotation. The data needs to be organized and so on. So with this comment, I will finish, and thank you for your attention.
Thank you. Thank you, Maciej. So I learned two things, that musicologists and you have the same problem, noise. And that my irreproducibility of making coffee on my manual machine is absolutely normal, because even robots do the same. Okay, thank you very much. I have one urgent question, because your ultimate test is a fire test with 1,200 grade Celsius for 6 minutes. How often the fire alarm is activated in your laboratory? So
and now we are building a new rig in a new facility that this will be aligned, but it's in a chamber, and actually the norm the norm specifies that it's actually a testing chamber inside another safety chamber, which is properly ventilated.
Perfect. This is a semantic context I wanted to bring up before next or wherever, and before our second speaker, Patrick Lambry from University of Linköping, and I didn't introduce Maciej, and I will not introduce Patrick because he will do it.
Okay, thanks. So my name is Patrick Lambrix. I'm a professor at the University of Linköping at the Department of Computer Science. I've been working with AI since the 90s, but the old kind of AI, which is AI knowledge representation. And nowadays, this has come back in the form of knowledge graphs, and this will be the topic of my talk. 20 years ago, I worked a lot with people in the life sciences to help them manage their data. Nowadays, it's mainly with people in material science. So I will talk about managing materials data, and I'm not a material scientist, so if I make mistakes, I just blame it on my ignorance, but you're very welcome to tell me that I'm wrong. There was also a little star in the previous slide. And sports. So sports, watching sports is my hobby, you can see that. And nowadays it's mainly ice hockey. So I like to watch all the games of the local team in Linköping. And some years ago I had to figure out a way to convince my wife that that is okay. So I started doing sports analytics as well, with a focus on ice hockey analytics. We actually have quite a good team now. I mean, the research team, not the hockey team. And I actually organized the largest ice hockey analytics conference in the world. It will go for the 5th time in Linköping. And whenever I watch ice hockey now, I can tell my wife I'm actually working. And then she says, okay, go ahead and work. I'll come back to sports. So, why are we doing this? Oi, this was not how it was in my slides. This looks nicer, but still strange. Okay. So, I've worked with people in material science, and mostly people who are doing computational material science. And they have stored quite a lot of data in different materials databases. They want to use these materials databases when they are looking for information to create new materials. And most of these databases have their own APIs. And a data-driven workflow, which we have already seen, they will actually search these databases to find, for instance, properties of materials. Okay. So here's an example of some of these famous materials databases, NOMAD and Materials Project OQMD, where if you look for gallium nitrate, you will actually get different kinds of information back. So the different databases have return actually different fields. If you look at the formula, here you get the simple formula, but NOMAD actually gives you back a more complex formula. We actually don't know if different things really mean the same. From what I've heard, the band cap is a tricky one in material science. Many people have their own definitions. So what you would like to do is to be able to query these different databases in an integrated way, but also making sure that the things that you get back mean the same from the different databases. So there is a first step, which is made, for instance, by Optimate. Optimate is a large consortium in Europe, which connects all these important databases in computational materials science. And what they've done is they have designed a common API, so you can actually query many of these databases using one API. And this makes the materials databases in some way interoperable. But it's still only a first step. What you still don't have is the semantic part. So you do have integrated access, but not the semantic integrated access, showing when different things mean the same thing. And this is kind of work that we are doing, inspired by Optimate together with people from Optimate. We're going to use ontologies and knowledge graphs to create this semantic access. And it also makes the data a bit more fair. Fair stands for findable. You need to try to, it will be easier to find where the data is. Accessible, how do you actually access the data when you know where it is? Interoperable, how do you connect? Do the things mean the same thing? And then reusable as well. And this fits well with the self-driving labs or even digital twins. And I chose digital twin because I knew you would talk about self-driving labs. Where, I guess many of you know digital twins, where the idea is that you connect the physical world with the digital world, which has different, which models the physical world, and there's interaction between the two. So if you talk about the cognitive digital twin, some people call the semantic digital twin, you would add cognition, where the idea is that the digital twin will also recognize complex, unpredicted behavior and also generate strategies and can act upon that. And this means that you also need reasoning, you also need prediction, you also need decision making. There's also full life cycle management. You would like autonomy so that you can act without human assistance, and you get much closer to the self-driving labs then. And it's also evolving by updating itself according to changes in data. And then also each model changes dynamically. So this picture is taken by a paper from the CIIRC group in Switzerland, where they showed and the physical, this is still the physical world. You have the digital world, but now the models evolve themselves as well. And you have a semantic layer where you have ontologies and knowledge graph that connect both the physical world, the digital world, and connections to each other. So let me talk a little bit about what these ontologies and knowledge graphs are. So in addition to Marek, my main connection to Czech Republic and Prague is that we had, now we get back to the sports, many good Czech players in Linköping. We had Jaroslav Linka, Jan Lavac, Josef Melichar, and nowadays Jakub Vrana has come back. So I'm going to use this as an example of how we can build a knowledge graph based on this little story and knowledge. So we have the knowledge that teams have at least 2 members. Large team has at least 10 members. Sports teams are teams which have only athletes as members. Ice hockey team is a team with at least 20 members, and all the members need to be ice hockey players. Ice hockey players are athletes, well, some of them anyhow. LOC, that's my hometown team, Linköping hockey team, is an ice hockey team, and it has Jakob Vrana as a member. So how can we represent this? It seems not. Okay, there we go. So this is what you can extract from the story. And in knowledge graphs and ontologies, you would define concepts, you would define relations between the concepts, and you would define axioms. And this part is the ontology part of the knowledge graph. So the things in blue are concepts, teams. We have relations, member, and then axioms state facts that are true in your domain. So for instance, every team has at least 2 members. Every large team is a team and has at least 10 members. What I didn't show is that this at least and they're actually logical constructs. And these you can also represent. And I will give an example later on. So if we visualize this, from the story I will know that every sports team is a team, and I represent this by an arrow. Every ice hockey team is a team, every large team is a team. Every ice hockey player is an athlete. Sports teams have athletes as members, and ice hockey teams have ice hockey players as members. Now this visualization lost some information actually. I don't have the at least so many members anymore, for instance. And I don't have the all members need to be ice hockey players. So it's not the best visualization, but it's the one that people usually understand. But when we've modeled this information or this knowledge, actually we know something more. When you do reasoning, you actually also know that every ice hockey team is a large team. Because an ice hockey team had at least 20 members, large team have at least 10 members, so every ice hockey team is a large team. And every ice hockey team is a sports team, because ice hockey teams have only hockey players as members, hockey players are athletes, and therefore every ice hockey team is also a sports team. So actually, by writing down this part, you actually also know this part. So actually, if you have a reasoning mechanism, you get these things for free. And that is exactly the advantage of using ontologies and knowledge graphs, that you don't need to state everything, but you can have a reasoning system that will derive new facts from old facts and the actual deductive reasoning. We also had Jakob Vrana. Well, we know that LOC has an instance of an ice hockey team, and we know that LOC has Jakob Vrana as a member. So the actual entities, the actual objects, the actual data are called instances here. So I've added those two, Jakob Vrana and LOC. We have member relationship here, and we know that LOC is an ice hockey team. Now by adding these two statements, I actually know much more. I actually know that LOC is not just an ice hockey team, it's also a large team, it's a sports team, it has at least 20 members, all the members are ice hockey players, and all the members are athletes. And I also know something more about Jakob Vrana. Well, he is an ice hockey player, and he is an athlete. So again, by having stated the story, you actually know much more, and all the yellow arrows you actually also know. And again, a reasoning system can derive this for you. Now this seems very simple, but in general, when we do reasoning, Humans are very good at 7 plus minus 2 steps. A reasoning system doesn't have that kind of limitation. So if you have very complex reasoning with many steps, it can do it for you, even when you didn't think about it. So a knowledge graph is a structure, the ontology, plus the data. And now I've shown you text and I've shown you visualization. What we actually work with is description logics, and this is how we would represent it. This is a relation. A team is something that has at least 10 members. A large team is a team and it has at least 10 members, and so on. And then we use description logic reasoning systems to generate all the consequences of our knowledge base or knowledge graph. So how can this help us with a framework for semantic and integrated access? So what you would like is to have a system where you can query in one way, like an Optimate that has one API, multiple databases. The query answering system would for you figure out which databases to use, would send different questions, queries to the databases, get back answers, merge them, and send the final result back to you. And the way that we want to do that is by using a knowledge graph-based approach, where we will developers, and this has to be one time, have to create an ontology, or you can use an existing one, create mappings between the ontology and the schemas of the underlying databases, and then hopefully you can get such a query answering system. So I'll give an example of what one of my previous students did. So we created together with domain experts, because this is not something that we computer scientists can do. It's also probably not something that domain experts can do. You always need a combination of domain experts and knowledge engineers. So we created the materials design ontology, which is used by several groups nowadays. And one way to create such an ontology is starting with competency questions. Try to figure out what are the questions that you would like to pose to your databases and get answers to. And these were some of the questions that our domain experts had. What are the calculated properties, their values produced by calculation? What are input-output structures of a materials calculation? What is the space group type of a structure, and so on. Now, what is interesting is that for all of these questions, the data to give you an answer is in the databases. But for the ones in red, you could actually not get the answer out. It was there, but there was no way via the API to actually get the correct answers to this. So we created the materials design ontology. Is a relatively simple ontology which has 4 components. We created it in a modular way so that it's easily extendable. So there's a core component which talks about the basic property, the basic concepts. What is a calculation? What is a property? What is structure? And you have 2 kinds of properties: calculated properties and physical properties. This is how it really looks like, again in these description logics. So a calculated property is a property, a physical property is a property. Something cannot be a calculated property and a physical property at the same time. That's how you read the logics. And we have some more description logic statements for doing that. And there's a part about the structure of your materials. There's a part about the computational methods that were used or can be used. And there's a part about the provenance. So who has been doing what, which algorithms were used, or which software was used. And then using this ontology, you can instantiate it with data to get a knowledge graph. And here is one small piece of a knowledge graph based on computations that one of my colleagues has performed and published. So for instance, if we look at this node, this represents a calculation. Here we have some information about which methods were used, and here WASP was used. Here we have the provenance information, so Ricard Armiento is somewhere there. He is my colleague, yeah, here he is, who created this computation. Here we have information about the actual structure of the materials. And here we know that, for instance, it was band gap that was measured, and here we have electron volt and energy, for instance. So you can instantiate your ontologies using these, and then using your reasoning mechanism for figuring out all the missing information. So one of my students actually created a working system for this. We used GraphQL as the representation language for the query server. The reason was that it was a new kind of method which sounded promising. Nobody had done integration yet, so this was also good for computer science. But the nice thing is what he did was we used MDO here. He created mappings between MDO and different databases. And then he implemented a system where if you give this as input, it will actually generate this for you. So you don't need to implement a search system, just use his system, input ontologies, input mappings, and you get for free a server that can access these databases in an integrated and semantic way. He evaluated this with some of these well-known databases. He compared it to other kinds of GraphQL databases. The lessons learned was that this was the only system, because we used ontology, of course, that could answer all of the questions, also the ones in red from before. And time-wise, we were doing equally good as most, a little bit worse than one of them, but that one, okay, I'm not going to say cheat, but it did some storing of preliminary data, which we didn't. So let me finish with saying a little bit about other work we're doing. We're also working with people in the additive manufacturing field. Their problem was that they're doing experiments, they want to learn from the experiments and then change their processes, but they didn't really know what kind of data they should keep. They stored some data, not all data, didn't know what was interesting beforehand. So what we did was we worked with them to create an ontology for processes in additive manufacturing, and these guys were interested in electron beam powder bed fusion additive manufacturing. That helped them to learn about their own processes, to learn about what kind of data could they actually store and what could be interesting for them. And then it's important to give tools to the people to actually help them doing this. So we have implemented tools that, for instance, generate knowledge graphs and data from ontologies. We are creating tools that help them to input the data from their processes, from their experiments. We also try to automate as much as possible, so that at the end they have a nice knowledge graph which they can query and actually figure out what to do with it. We also have some tools for extending ontologies, and this is one of my main fields of research, doing quality management of ontologies and knowledge graphs in terms of correctness and completeness. You want to make sure that as much as possible in your ontology and knowledge graph is correct, but it's still software, so there are going to be bugs. So how do we find those, and how do we repair those? And the same for knowledge graphs. And then let me finish by introducing materials commons for EU, where several people here in the room will collaborate with us. This is a European project that will start in June. The project leader is Fraunhofer. We are about 26 universities and research institutes, and who will share the money, 28 million euros. And then about equally many industry partners who will not get money, but they're still interested. And our aim is within 4 years to come up with a governance structure and a technical solution to seamlessly connect researchers from both industry and academia. The idea is that they can produce data, share data, and consume data in an easy way. And the technical solution will be based on knowledge graphs. Thank you.
Thank you. Thank you very much, Patrick. And I learned from your lecture that if I want to make the right coffee for ice hockey, to watch ice hockey match, I need a knowledge graph because I need to introduce the context. Coffee for ice hockey may need some different parameters than coffee for gardening. Okay, good. One quick question. You mentioned competency questions. Would incompetency questions help?
I actually think so, because it does tell you, I mean, with the competency questions, you create a search space. The incompetency question could actually reduce that search space a bit. So probably yes.
It was not a joke, even though it sounded like. Good. I'll ask you to sit down here and be ready because you've seen surprised with the font you've got. This is Prague. In Prague is famous for Golem and Franz Kafka and other not always straightforward situations, I would phrase it this way. Maciej, please take a seat. We follow with a panel discussion, and I will ask Michal Tarana from Heirovský Institute, Czech Academy of Sciences, and David Novák from Institute of Archaeology, Czech Academy of Sciences, to join us. And from research labs and offices, it sounds good. Not only labs, also offices. To semantic web and self-driving systems, you heard the two talks, which were supposed to warm you up for questions. And I will follow up with a question which has something to do with the incompetency questions. Because in the session with our colleagues from CIIRC, we heard about the importance of data. They need data. And we always, when we speak of data, pretty much always think of a so-called positive or good data in terms that this is what we wanted and this is what we will share. But there is a bunch of data which are probably extremely useful, and they are so-called negative data, or better say, data which have everything okay, that the experiment or computational simulation was done absolutely perfectly. They don't fit our ideas, so we throw them away. Maybe these data are the critical to improve our systems, and this will be the first question for my panel to start with. I will do it this way. First, I will ask David and Michal a little bit to introduce themselves and tell us their view on negative data, please.
Okay, thank you. To introduce me fast, I'm actually an archaeologist, but I'm high level involved in building research data infrastructures as I'm working on a national large research infrastructure, archaeological information of the information system of the Czech Republic. And we are trying to develop, of course, as a core repository for digital data in archaeology, and as well we are establishing some like research environment around which helps people both to administer data because we are involved in handling the legacy of all the fieldwork which is happening in Czech Republic and store the fieldwork data which is being created as a primary input for the archaeological research. And then as well we are trying to somehow process this to be somehow understandable and reachable for the from the outside, both from the for the professionals and as well for the public. So we are trying to target several different audiences. Yeah, I didn't mention I'm based at the Institute of Archaeology of the Czech Academy of Sciences in Prague, and we are collaborating on this topic with the same institute seated in Brno. So that's maybe a short introduction.
Thank you. My name is Michal Tarana. I'm a colleague of Marek Cebecauer at the CIIRC Institute in Prague. And I'm also involved in the National Data Infrastructure project, where we are building the infrastructure for storing and sharing and managing research data on the national level. More specifically, I'm involved in building the repository for material science research and the related metadata models and all these things. I'm also dealing with electronic laboratory notebooks as a scientist's side of the story, as a piece of software that is close to the scientist, and that helps to streamline the publication of the data and metadata in the national repository, and also creating and these days I would say researching the workflows, the automatic harvesting of data and their annotation and their publication in the storage. To address Marek's question, my view of the negative data, actually my background is in theoretical physics and computational physics, where a lot of times what we do is we test the hypothesis, and we do the calculations, we do the simulations, we have some idea, and we build some model to explain some behavior of the data. So we test whether certain data fit the model or partially fit the model or do not fit the model, and based on that we explain certain phenomena or claim that we have not explained them successfully. And so the negative data is inherent part of the story, and actually what quite often happens is that we come to a conclusion that the explanation of what has been challenged at the beginning is more simple than we anticipated, and that the original model is kind of overly complex, and that there is a easier explanation, and part of this is thanks to the negative data. The only thing is that, at least in my part of physics, we don't really market it in the papers as negative data. We just draw more simple conclusions and more and let's say less exciting conclusions than we originally aimed to, and we don't refer to it as to negative data, but they are inherent part of the story, and I think that similar approach could be applied in the material science to some extent, and that the systems that we are building and that the approaches that we have to data management should reflect this. Thank you.
My comment on this question of importance of negative data. I think in the materials discovery or chemical discovery field, it's now well established that we need negative data to build accurate models, and we see the trend that some publishers require that you basically publish the data set before your paper is accepted, the paper that shows a machine learning model. So I think there is a changing trend in this, and there is already recognition. It was missing maybe 10 years ago, but now that there is a recognition that we need complete data sets. That there is another aspect that now I start seeing moving more into experiments is what do we do with failed experiments that we don't know why they failed. Because we're thinking about, let's say, computational models, we usually have consistent data. So all the data set was obtained using one method, one computer program, one simulation tool. And then basically, even if we have negative data, it's usually materials with some less interesting properties, but everything is consistent. But if you think about laboratory work, there are many ways why experiment failed, and I think that there is a risk that there are different failed experiments, and I'm not sure if we can put them into one bucket. And that's something I don't know the answer, but I suspect that we need better tools, and maybe this is something actually that ontology can help us with.
Yes, I would say that negative data is positive. When you get positive data, it corroborates what you know. When you have negative data, you have a chance to learn. When we help people developing ontologies, negative data could be that there are things that are wrong, incorrect in our ontology, could be things that are incomplete, so things that are missing in ontology. So in both cases, we can learn. When there's something wrong in ontology, you have to figure out what to take away, and you learn more about your field. If there's something missing, you need to find different ways to add them. Usually when we do ontology engineering together with domain experts, I don't know anything about their field, but I ask annoying questions. Usually the questions that I ask are, okay, you say this, so that means that this is a consequence. So I just use logic to try to reason about their field. And then they can say yes or no. And when they say no, they actually say that, yeah, we actually learned something about our own field. Because they have to be very precise, very clear about what they mean. The one tricky thing is, and you touched upon that, for instance, in data mining, what is negative data? There is a fine line between outliers and noise. And again, where does it come from? Why did we have a failure? And that's not always easy to figure out.
Actually, in my introduction, I completely avoided the question, so just to supplement this, my answer, working with negative data for archaeology is somehow inherent, because if we go into the field, we often do not know what will be there, and the current archaeological fieldwork is usually driven not by the research question primarily, but by what is happening there regarding developments, and we are just trying to save what is there. But still we are trying to somehow keep the science in. And so we try to record everything, and I would say 90%, it's between 10 to 5% of what we actually get from the 10,000 project we do each year, or we have a recording of each year, is positive, but the rest is the negative evidence actually. But the funny thing is that what is actually considered negative evidence, it changes through the time. As in 50s, anyone would say that if they hit some medieval situation, it is negative evidence. Today, it's completely different, and even with modern evidence, evidence of industrial eras, we collect this data. We know it is important for us, for the research and so on. So actually, as has been said, there is no actual negative evidence. That is just some observation which is or isn't recorded. And we definitely work with the data. We know it is important for the reflexive approach to the data, and being assured that the reasoning behind how the data were created is somehow captured. So it is definitely important.
Thank you. I have asked because my experience from my field, immunology and biochemistry, is completely different. There is almost zero data which are not in line with our hypothesis. They are not shared. And the problem is what Maciej touched, that we do not know what is the reason. But thank you very much to turning my negative approach to kind of positive, because the positive approach I expect from our audience. Do you have questions to our panel, or immediate questions? Yeah.
Okay, negative and positive data. came across the term in social sciences, lossy data. Have you ever? No? Okay.
We have social scientists, lossy data. Okay, no. Not even social scientists heard about it. So it's probably a robotics social sciences specialty. Okay, but thank you for asking, because that's probably warm-up question, even though it was one of those failed data resources.
I do know that there are some terms in databases which is lossy and lossless data. I don't know the exact definition, but if I may have an educated guess, lossy data may be that you actually don't manage to represent all the information or knowledge that you actually gathered. And in that way, your data is lossy, that there was actually more data than you actually stored.
Of course.
Well, coming from social science, it's exactly what you are talking about, because it's much more complex. You have many more variables, right? So I think that's why it is important, this concept, because it shows that that scientists should be kind of sometimes careful about thinking about fullness of knowledge, or there is certain arrogance in science, and I think this term brings us back to reality. So that's my understanding.
So I've mainly worked with people in the natural sciences, but I've heard from colleagues that when you try to develop ontologies in social sciences, much more difficult.
Yeah, I can somehow confirm, probably, despite not being social by humanities, but still the similar issue. What we trying to employ is some selection strategy in there, and this is we are aware what we are at least partly losing, because every time when we collect something and collect some data, we cannot never capture everything. And it especially applies as we are working with like physical material, which are trying to somehow extract from the field. We need to somehow describe what we left there and what we left there intentionally. So this is how we approach this. It is developing some coherent, negotiated selection strategy. Why is something taken and why is something kept, didn't taken, or even thrown away after analysis, and so on. So I think that this is somehow well related with provenance, that we need to record the decisions we made and have actually the decisions somehow pre-thought before we do the actual workflow.
Okay. Coming back to the title of because there are no questions in the audience immediate, continuum between data, AI, automation, and robotization. We've seen two presentations. One was more on the side of a consumer, data consumer, and one on the interpretation of the data, bringing the context. But even during the session before the lunch, this was largely that the data were flowing inside one system. And Matej confirmed that in your case it's similar, that you largely build on your own data. How to do it? This is, I know it's dominated by physics and material science, but on the other hand, the archaeologists bring here to helps me with my question, because there is a thousands years of knowledge about materials. So archaeology can provide material science knowledge for reasoning, for argumentation in material science research. So how to bring all this information to my research? If I would have a lab like you, or there was Stillman somewhere, with your point of view. Yeah, I know you have more semantic, you have more practical. So how to bring all this data to my benchtop or desktop, whatever I do? Who wants to start with this complex question?
I guess Materials Commons for EU is going to work towards that. But I can give you an example from ontology engineering. So even in ontologies, I mean, we saw that there's a problem with the databases, that people make their own database. And so actually the same happens for ontologies, that lots of people have been creating ontologies. People have been creating mappings between them. But when we work with repairing ontologies, trying to find mistakes, it's clear that if you're allowed to use other people's ontologies and the mappings between your ontology and others, you can repair in a much better way both the whole network and your own ontologies. But of course, people may not allow you to change their ontologies. You may actually find mistakes in others as well. So we actually did some theoretical work on defining different autonomy levels where people would work together completely, or you only allow to other people to use your data but not change, or you don't even allow to use the data. And you can easily see that the more cooperation you have, the better quality you will have for your knowledge graphs. But if you don't want to share data, you can keep yourself at a reasonable level, but you know that it's not going to be perfect. And this is going to be the same when people have their own data. What do you want to share? What don't you want to share? We will need to make a governance model in Materials Commons. Do you share data? Do you allow people to use your data, but they have to send their programs to you? You do the calculations, send back results. On which level do you want to be? But the more cooperation, the better results you will get.
Okay, I can comment also from practical point of view, like running the lab. So, for example, in our case, when if you think about, let's say, you optimize processing to get not only composition but processing of a material. There are many parameters involved, and you have to optimize at which processing parameters you get the best material. And you have to think that every experiment, even if it's automated, even when it's guided by AI, is very expensive. So right now it's estimated that one data point in material science is between 500 and 5,000 euros. So even if automation decreases by 20x, it's still a lot of money because you will need hundreds and thousands of experiments. So we would like to reduce number of experiments, and one way to go is to try to learn as much as possible from other people's work. So in some cases you have databases that were created in recent years, but chemistry and material science is very organized field. Like if you go to any good library, university library, and you look at the journals of, let's say, American Chemical Society, which is one of the top journals in chemistry. I think the first issue was in 1880. So you have 150 years of literature, and there is lots of information then on the people who tried, successful experience, so on. So one way to go is to try to read all those papers using automated, LLMs methodology, and organize all the information, knowledge graph, and then basically try to query this knowledge graph before you try in the lab.
But then you will have a lot of gaps, because that's a problem of a current journal article system, that you have a fragmented information.
Yes, but then at least you know that it's worth spending those euros for an experiment to try it. I think what you try to avoid is repeating the other experiments, unless you want to.
Yeah, of course. But as I said, this is my question was going really towards how to use this information in your practical life. How much do you use information? I know from a standard chemical databases, yes, but from a competition labs, or is it possible?
I think we still have a problem. It's a learning problem. This methodology is just too complicated. It's not a standard course that the students come to your lab and they know how to do it. And it's still quite new. So, let's say knowledge graphs, I know about them, but we are not actively implementing in our lab. We have few small pilot cases, but it's not something, we should be doing more of it. I think there's enough evidence, is enough momentum that we should be doing more of it. But it still, for a small lab, it's just too costly, I think, right now. I think hopefully programs like Materials Commons with better tools, with better manuals, with all the efforts with summer schools and training will make it much more accessible. But I think right now, as of today, it's actually quite complicated to implement this methodology in a lab.
My 2 cents to this topic from the perspective of the infrastructure and of the software that needs to be really deployed either on the national level or in the labs at the end of the day, is that it's actually related to what you said before, that we really have these graph approaches that are very systematic and that are very promising and that are very consistent, that are very nice. On the other hand, we have very well established software products that are for the repositories, that are for the laboratory notebooks, the workflow orchestrators, and all this. We have GraphQLs and APIs and all the technologies, but there is still a gap on the software level between these graph approaches and between the software tools that are currently available nowadays. And I'm very happy that events like this can help to narrow this gap a bit. But this is really essential, I think, because we know how to gather the data and how to gather the metadata. We have some ways how to control the quality, how to control the requirements of the data, that we store and that we take into the system. But then, on the other hand, to really provide them, including the context, that's currently very challenging. And that's also one reason why we are involved in Materials Commons to narrow this gap. And for me personally, this is a big topic these days, where I'm trying to kind of make some proof of concepts to integrate these two worlds together. But I think that this is really essential for bringing the data really to your lab. Thank you.
Yeah, actually, my thoughts somehow nicely fits what you have been talking about. But in general, I think that the current tooling which is brought by AI shows how the answer to that actually question can differ in time, because now I see that the biggest issue with the data we have is not the format or the actual data representation, because this can be relatively, not easily, but changed, and it can be actually transformed using some actual ontology to the more useful data set. The issue is with the inherent quality of the data set, which is given by the practice when collecting the data. And so we did put a lot of effort in past to, for example, reshape the data into databases and create some different formats. But it turns out that now the biggest issue is what actually is happening in the field, how the things are documented, who did it, how educated are the people who do the actual data collection, and if this is if the quality is present there, and their information are at least somehow transferred into the data, even in writing or recording anything, it can be working with. But the issue is if we capture this and who does it. So I think, for example, the meaning of fair and what is fair data somehow changes, because previously we would say it's extremely coherent, interoperable data. But the thing is that fair by design means how I can transfer my knowledge into something what is time proof.
Okay, thank you. So we have some indications what to do. And thank you for mentioning that it is important to know who provided the data. And sometimes those who are the biggest experts are more senior and write on the paper. And this week I heard actually from one of my colleagues, not in Prague, but online, that the AI will help to convert these handwritten notes into the data or knowledge in this system. So what is your opinion? Is this possible? Because there is also a semantic issue, yeah? If I write my notes, the semantic mapping is very difficult to do my semantic issues in my notebook to some ontology or whatever. So is this possible?
I would say, I hope yes, because we have a running project specifically for that, trying to somehow extract the data from the written resources we have. It is complex, definitely. It's have its caveats, but in general, the text recognition or automated text recognition developed so much that now you can relatively safely transfer almost anything, even in handwriting. Of course, it might be complex in some cases, but it works. Then the natural language processing developed also so much, so you probably would be able to extract more coherently and more information that the human would do if doing that by hand. And we did it for tens and tens of years. We did this for our databases, so we are definitely reaching the point where actually, and that was I was mentioning before, that we would be able to somehow start skipping that in between step to build the structured information so much and just record what we see in the natural language in a way that it is like how we feel it, and the actual recording, the data which we will produce will be of better quality than we will do this on purpose. I believe this is the way which we are like reaching.
Well, this is not really my field of expertise, but from the little experiments that I do in this field, I see that the possibilities how to turn the unstructured data into structured data in general is greatly improving. So as a kind of bystander and occasional wanderer, you know, of this topic, I really see a lot of advancement in this field. So yeah, I have high hopes.
I would agree that I think that in current situation, even if we can, there are some special cases where we cannot interpret this data, we can just flag it and just leave it for later, or now use it with caution, and in the future maybe we can revisit and improve it. I'm thinking, you know, about the crime investigations with DNA samples that now you see in the news, that, you know, they had a sample taken from the 80s and only now they can match, or they can match, let's say, they find the criminal based on the public data, or those services that catalog the DNA to like ancestry kind of website. So I think will be the same with other kinds of data.
Yeah, I think that LLMs are great tools if you know how to use them. People are starting to use them for creating ontologies, for instance. But there are a number of things that will be difficult to really do. Maybe one of the biggest success stories for ontologies is gene ontology. Started over 20 years ago. It's actually still ongoing. I did the mistake of signing up for the news group. And so almost every day I get some mail that, yeah, we are going to deprecate this term and we add these things. But this project, Gene Ontology, was funded both by European Union, the National Institutes of Health, and also the major pharmaceutical companies, because they thought this is pre-competitive and it's good for everyone. But Michael Ashburner, who started this project, he used to say, it's easier for biologists to share their toothbrush than their definition of gene. So getting into an agreement that is shared by experts all over the world is not such an easy thing to do. I don't know if LLMs can solve that.
Again, as always, you prepared me for a next question, because you have this semi-autonomous system, and semi-autonomous system has to do decisions relatively quickly. In your lab, maybe it's slower, but then I've seen some labs globally where the decision has to be made in fraction of seconds sometimes. So if I will provide this system with all the data we have, there's no way that in milliseconds something can be done. So how do you see what can help in this direction? Of course, there is probably a limited number of information which is needed in this particular case, but who will decide, or what will decide which information is available when and how to prepare it? What is your opinion? I know this is a little bit strange for archaeology, but even in archaeology, probably you can have use cases when decision has to be made relatively quickly, which in this particular case is maybe not milliseconds, but still quick enough, and the current systems are not supporting it yet. Okay, let's start on the other side.
Yeah, that's a tricky one. One solution that we have been working with is that you don't need to do all the reasoning for the knowledge graph during query time. So what you can do is doing as much reasoning as possible beforehand, trying to figure out for particular applications what are the important things to know, and then materialize, so that these things go very fast.
I don't have much personal experience, but I remember my colleagues when I worked in Berkeley lab that there was lots of discussion about embedded AI for the light sources, for like synchrotrons and Large Hadron Collider, that they produce so much data that they cannot send it. They cannot even analyze. They cannot even send it over the network. So they were thinking about what would be the kind of first layer AI that can do some preliminary. But this is really not the project I was involved.
So preliminary filtering.
Yes.
Okay.
But
so in your system, there is never such a time pressure?
In our experiments, not really. Also our models, we don't have that much data. Like we decide on new composition we want to test, and basically the AI runs much faster than experiments. So we don't have this problem. There is a similar problem in manufacturing. So for example, if you think about, let's say, if you use injection molding or like resin injection when you do composite parts, what you want to do is avoid defects, and it also matters because of cost. Like if you produce for example, I know the case of elements for an aeroplane that's something that a colleague in our institute investigating. So right now there are certain elements that cost, for example, 20,000 euros, and only 1 in 100 is good, passes all the tests. And it's so what they're thinking, for example, embed lots of sensors in the mold and basically monitor the process as the resin is injected, and then trying to manipulate using AI injection pressure and so on, try to make the part without defects. So there's lots of research in this area on using AI in manufacturing. But again, this is not my field. I just know that this problem exists and there are good researchers working on it.
Yeah, I just wanted to comment on that. Also not my field, but there's a field called stream reasoning, where there are two different ways to deal with data. One is you're only interested in outliers. So think about a bank that is looking for suspicious money transfer. What they do is they look at the stream of data that is coming and only pick up the things that are suspicious. The other one is where you want to store as much data as possible, but too much data is coming in too short time. So what they may do is to look at the window of data, compute an average, for instance, or whatever kind of aggregation function, and store that.
Yes, the real-time access to the data that is also produced and that is streamed in real time. That's really a topic even beyond material science and beyond decision making. There is whole area in computer science dedicated to low latency access, and unfortunately from the infrastructure point of view, for various reasons, we are actually even introducing further barriers that delay the access to the data. Yeah, for example, nowadays when you deploy some system, like repository or so, it will have by default set some rate limiters and some things that improve the security, and they improve the local performance of the system as a whole. But on the other hand, they create a barrier to access to the data in real time, and that further complicates this fast decision making. Then related to that, there's a problem of the trust zones, that you have certain places from which the data can be accessed at higher rate because you simply trust that partner more, and there are other places that you trust less, and you want to limit them. So I think that this is going to be a matter of subject and a matter of research and a matter of experimentation for coming years, as the demand for this low latency data access for quick decision making will increase, and as it will create pressure, then this will have to be addressed. But there are many strictly on the technical level. There are many obstacles to this.
Yeah, of course, we in our field are not dealing with that kind of speed or the levels you are speaking about. But in general, there is some time pressure, because any field work is usually constrained by some like time resources and money, and as well it is. In compared to other fields, it's specific the way that it's repeatable. Usually, it's invasive, and you collect what is there, and you have just one try to do it. So the issue is how to do it properly, and how to. So you need to take a lot of decisions at the spot, and to record them properly and to take the right decisions. This is difficult. So definitely being able to somehow facilitate that process, that the decisions are better recorded, that we are able to capture more data. This is also a concern for us, because, for example, when we use 3D scanning, the volume of data you can produce with 3D scanning to capture and I think it's tremendous. And actually, we reached even the data sets we are actually considered that they are not useful anymore as they are too big. So there is so few people who actually can process them that it is unfeasible. So it is better to have lower quality data because actually it can be processed in practice. So it's every time about balancing some resources, and these are often like difficult decisions. Yeah.
Yeah, I'm very happy to hear this because I'm from imaging part of the world. What does it mean, big data in this case, which you mentioned that we are at the edge of if to keep it?
Yeah, actually, if you really scan some very complex situation, it can be like tens of terabytes of 3D data just for one situation, which is actually so much that it is hard to process on any like common hardware, which creates constraints because the institutions which are involved in the field are often like very small museums and the companies which are not so well equipped for such types of data, and that creates friction.
This is really interesting for me because in archaeology, I would expect that I would like to collect as many data as possible. Just for you to explain why I was so immediately involved is because I come from a biological imaging and there is a field which is called light sheet microscopy, which is just scanning 3D objects, and it's generating enormous data, which is in the range of terabytes per few hours. And you can have many animals, so you can create 100 terabytes in a week or two easily. And the agreement in the community, if you, for example, analyze a fruit fly and its development, is that you analyzed it, you acquire data, process it, delete raw data. The reason is very simple. You can have as many fruit flies as you want, and no one cares that the next fruit fly will be slightly different. So it's very easy to repeat the experiment. I had a friend at the Faculty of Sciences in Prague at Charles University, and he asked me the question that he has some lizard and did the image analysis of this lizard, and it's, I don't know, 50 or 100 terabytes of data. Should he delete the data? Because I think it was mentioned that in, let's say, 5 to 10 years, there will be better analytical approaches to get even more information from this data. My question was how often you see this lizard? And he said, well, this is probably first time or maybe once in 20 years. So I told him, store the data. Raw data, 100 terabytes is nothing compared to the fact that you will not see this, and this is a kind of raw animal from nature, so you don't want to. You can have a new scientific question, so you will hopefully will find. So in archaeology, I expect that it's even worse, because in 2,000 years you probably will not see something like this. So how it is?
Actually, it's a lot about resources, because archaeology as a field have to advocate for itself all the time, because the most of the field is paid by the individual developers, by people who are forced to pay for the research, and so you are in the constant negotiation of what is feasible, and as well building all supportive infrastructure costs money. Of course, now integration into some national solutions brings some new options, definitely, for such stuff. But still, in general, it is actually more feasible to capture the point and the ideas and the main messages, and not so much unstructured data. Because what we even see in the past data is that of course, we have extreme amount of legacy data, but the people who are actually working with it in detail, it's so few. We have a lot of people who are just coming and taking some like basic ideas and some already synthesized version of data, but going into directly back into primary data, it is relatively rare, and it would make it just worse, because yeah, it will be even the volumes will be problematic. Yeah.
Okay, still no questions from the audience? Okay, so here we have a mainly research, academic research people, and we are developing our systems for academic research. I know that Materials Commons wants to bridge the industry. So how do you see our approach is useful for not only industry, but for example, society in general, in a more broader spectrum? Well, in archaeology, it's so I'm actually giving you immediately the word that we are developing. You heard it from Michal and others that we are developing new systems in Czech Republic. Actually, a new national data infrastructure. How this can be used by society in a broader meaning.
To translate, definitely every time you need to have some mediation between the original data and the target audience. As I have been introducing myself, I mentioned that we are trying to involve different audiences, and it is work. You need some communication strategy. You need some ways how to reach different audiences, and it's not happen just by itself. We have some very successful tools and programs to involve public, both some like citizen scientists and as well the general public. And every time you need to reach them with different messages, different data, different way of presenting the data. So it's a lot of work. Actually, it needs some specific experience, especially with some communities, so you know how the community work. So I cannot say, and I don't believe in it will just help as it is. There will be definitely people who are able to cope with what we produce, so not just browsing and harvesting what is around, but in general, it is a lot about translation it into the language where it is understandable. And I believe this is the role of humanities a lot, to be able to help with that.
And could actually AI help in this to accelerate this?
I believe so. I believe so, because of course, transferring the semantics into the another language, and it doesn't matter if it's like another mother tongue or another way of describing stuff, it definitely lowers the threshold and opens new options. Still, I think you need some specialized people who know how to actually seek for the information which is worth passing, and what is just the noise, which is every time problematic. For example, with some interfaces we know that they are full of data. If we introduce people into how it works, what can they get out of it? They are amazed about the volumes of information there, but without that, they are just sitting around and looking at, oh, what it is and what we can do with it. So it can help, definitely, of course, like implementing chatbot into any tool to just negotiate with the data. It's perfect, but still people are somehow overwhelmed with that, and it have to be as much frictionless as possible to be really useful.
I don't have much to add to this. I basically fully subscribe it because from my perspective and from my so far limited experience, what it boils down to is providing the interface that has to be generic enough to be used by as broad audience as possible. But on the other hand, at the same time to have a communication with the target audience and to show them and to tell them how to use these interfaces meaningfully, and eventually to build ourselves something on those that is understandable to the target audience. And yes, I believe that this is one of the biggest future benefits of AI, that the AI models, specifically LLMs and agents, that they can greatly help with this. I have high expectations from that.
I think I want to mention some other aspect of it that I think personally I'm thinking a lot about how what kind of data and how open it should be. So as a researcher and thinking about basic research, I would include cosmology, archaeology. I would include the medicine, although medicine is a complicated one because there is this commercial interests, right? We think about all the commercializing drugs that in big part are developed from public money, right? What do we do in this case? In my research, I sometimes interact with companies, we'll say, and seeing how they work, and also thinking about maybe as I'm getting older, I'm still mid-career, but you know, I have small kids. I think about the future. I think about this. What was mentioned in I think the first session, the competitiveness. If we collect the data using our taxpayers' money here, do we want to open it to everyone? Because there might be some actors in the world that are much better prepared to use this data, and they will use this data to compete with us, and maybe take some opportunities from us or our kids. And I don't have a clear idea on this, but I'm a bit worried, and I think we have to really think about it, because it's as taxpayers, it's our effort, and we would like to be in a situation that the taxes could be seen as sort of investment into the future. So we don't want to give it away. But I don't know if you become overprotective and you are not sharing, then you might miss some opportunities. So one of the reasons why I enjoy coming to meetings like this is basically to exchange opinions and try to see if we can compromise it somehow. So I don't have a clean answer, but
Yeah,
I'm thinking about my thoughts are going into this direction.
You mentioned the big source of data from American Chemical Society, which these years is not so fashionable, but we are a little bit more worried about partnership with America these days. And yeah, so where is the borderline, how to share these things? Yep.
But okay, American Chemical Society, it's a journal, right? It was published, and we have hard copies over here, right? So
not anymore.
In a good life, yes, you probably still have it in a story, but I mean that's yeah. I mean it's complicated, right?
Yeah, I'll get back to the question of how people will use AI, and so actually I think that almost everyone in this room has actually used Knowledge Graph the last week. I think most of you know this system called Google. If you search, you find this little info box that is actually based on a knowledge graph that Google has collected. And actually it was Google who coined this term knowledge graph. In the old days, we probably would have called it knowledge base.
And you mentioned Materials Commons, and Materials Commons is actually creating a knowledge base. This is how we called it, because we have a strong German influence. So we call it knowledge base of Materials Commons, the generic information for the European material science community. Still no questions? No questions from Zoom? No? Sorry. Are we so complicated or what? There are no questions. No, you cannot, because we are online. And you don't have such strong voice.
Thank you. So we've heard today quite a lot about high quality data, but it was in a sense used interchangeably together with the documentation as if they were standardized. But how do you view the problem of different researchers collecting it's completely in their right mind, different ways they are capturing the data, even though perhaps high quality and well described, but for answering different research questions. And now we would like to populate the graphs, as you've mentioned, to answer some other questions the secondary use of the data isn't all that easy if the data are collected in different manners. How do you view this as potential obstacle, or what to do with that? It's a very loaded question, isn't it?
There is no one to answer.
I would try at least something. Yeah, that's obstacle. It is. And that's why I'm so much stressing the process. That we need to start from scratch every time. And it's more, the quality is not about individual step. It's about the quality of the whole workflow, and being able to stay coherent throughout all the steps. And this is, I think, what concepts like fair by design brings us to, like, think about more in better detail. And every time standards are pain to implement, but in general I like more idea to implement principles than standards, because this is what helps people think better, conceptualize better. And it doesn't matter much which standard they choose, but the important is that they are clear about their concepts and are able to describe what they are doing in as close as possible to the reality. So if I somehow answer this, and that is what we should think about, how we should capture these processual decisions in the resulting data.
It is an obstacle indeed, and a very big one, and I basically don't have much to add to it. Just the prism through which I'm looking at it is the flexibility and understandability of the software involved. Because what I care about at the end of the day in my position is the final software that is brought on the table and that is deployed somewhere. And what I see is that the more opportunities you provide the users with to document each step of the process and to make the process more and more consistent, the less intuitive it is. And to find the balance between this, at least that's my view, that so and to find the balance between this is quite challenging, and I'm not really sure whether it is there. Yeah, whether there is a good trade-off between the complexity and the accuracy and all the semantic possibilities of documenting everything and still being relatively user-friendly.
This is perfect note, and I over time forgot to say it, but I feel it for a long time. We often forgot that it is used by people, anything we develop. And user experience is something what is so few times considered when we are talking about some new tools which are like developed for a specific field, but we still expect that if they should be used, they should be tested with people, they should be like proven to work in the way that we expect they do. So I often hit some perfect applications which have so terrible interface that that they are almost not useful at all. So that's a big issue, and I think AI can help a lot with that, because now the customability of any software changes dramatically, and we definitely should somehow think about how this, like, how to test if what we actually produce and transfer, if it transferable through the tools we actually provide for transferring the information.
I don't have many comment on the general case, but in some specific cases in a self-driving lab, there is this concept of multi-fidelity optimization, where you build a model or number of models on different data of different quality, and then you try to fuse this information. So you basically explore your space rapidly with a simple model, and then you just refine it with so there is mathematical framework that operates like multi-fidelity Bayesian optimization. So, but those are specific cases. I don't have much to add to general case.
I will first connect to your comment about the applications and so on. So this Michael Ashburner that I mentioned before, he said that there are three kinds of people that work with ontologies. The first one are the philosophers who really care about modeling the world. And they're the realist philosophers that, for instance, would never want an ontology about the Lord of the Rings or Game of Thrones, because these worlds are not real. They also don't care about how the knowledge is represented. So that means that usually you would have neat, extremely expressive languages where your reasoning may be undecidable. So it means that you cannot actually find all the consequences of the things that you state. Then you have the computer scientists like me who care about reasoning, who care about what languages you use, the complexity of the reasoning. And we don't really care whether it's real things that we model. And then there's the application experts. They don't care about all of that. They just want their application to work. Okay, so coming back to your question, we've heard today a few times more data is better data. So maybe we should rephrase this into more contextualized, high quality data accessible in a semantic and integrated way is better data.
Thousands of conditions. That's, yeah, that sounds like a fairy tale.
I have a semantic question and observation. I noted that you are using terms like collected data and similar, right? Now, as if you just find data, but data in fact are made. That's the title of the book, which is coming out this fall by Dana Boyd, and it's in the title, Data Are Made, Not Found. And the reason, I guess, you are avoiding this term made is that somehow you would imply subjectivity into the whole thinking. But my question is whether it would not be more precise to use this term made. And by extension, I would make same argument for the term AI, because it's misnomer. I mean, you hear very often, well, I don't agree with this term, but I have to use it because everybody is using it. But what if you just use data processing? That's what it is. And it's not just superficial, because semantic here is very important. It goes directly to ontology. So that's my question. Would you consider using different terms? Thank you.
So I showed you this small ontology which we made together with people from Optimate. Actually, Optimate started a working group where they wanted to create a relatively general ontology, and they made the mistake to start with what is a material. After 6 months, the group disbanded. But this is definitely an important point, but also a difficult point. So we have been discussing when you have material in an ontology, is this really the material, the physical thing? Or is it actually, because we use it for software, is it really data about material? And it's not maybe the same thing. So should we have representations of both things? The thing is that it gets very complicated and you get stuck. And that's why people avoid discussing that and just say material, it's there. And we get on with it. And that allows us to do data processing.
That's a complicated question. I'm a practical person, so thinking about changing the terms, I'm not sure if I would like to engage in educating my, in conversations and spend time with definition of those terms unless it's necessary. So I'm not going to engage with your question.
For me, this terminology that I'm using, and for me it's really collecting and managing data, reflects where I stand in the world of data and in the world of material science, where basically I'm trying not to process data. I'm trying to provide the tools for other people to process data. And I'm not trying to make data, but I'm really trying to collect them. For example, in the workflows, the data is ingested somewhere, it's stored somewhere, it's shared somewhere. And when someone processes the data, that's also part of the workflow. Does it concern me? Yes, it does, but I'm not the one who processes the data. So I'm also standing on a practical side, but not to avoid this kind of general semantic discussion. I will be very happy to hear it, but I'm trying to restrict the terminology to the point where I'm standing in the story.
I have it the same with Michal regarding the collecting data, because again I'm as well responsible for the repository, so that's why I'm speaking like that. In general, I would like more the term not making but creating data, if I can choose. But in general, the terminology discussions are often really complicated, and I'm not sure if we can come up with any term which will be agreed by all people. We definitely can't. And if we do, the philosophy would be like meaningless. For example, I experienced so many discussions. I'm a landscape archaeologist, and the discussions actually, what is landscape? That's like running through all the archaeology for a long time, and but the point is that the discussion is important. It's not about the term, and so we do not really need to have so precise terms. We need to be able to discuss the reasoning behind. We need to know that if we use some term that we are somehow basically aligned, we are speaking about a similar topic, but we should know that it don't have to be the same topic. And that's why the context is so important, as have been mentioned many times.
Okay, thank you very much. We are 5 minutes over the time. So I would like to thank the audience to stay with us with this not so easy topic. And I would like to thank our panel members, David, Michal, Maciej, and Patrick. And see you after the coffee break. And let's thank the panel members. Bye.
Ladies and gentlemen, I would like to welcome you at this afternoon and last panel of today's conference. And let's start before we all got excessively tired, and especially our speakers. So let's put all the rest of our energies into discussion now. Into discussion about what I would suggest is perhaps the most important topic, which I am not surprised would be in focus at the very end, because quite often this sort of happens with topics like ethics, responsibility, and so on, public goods in relation to technology. But I think that rather than downstream, this is really an issue that has to be tackled and addressed upstream when technology is being developed and sort of not stabilized yet, both in its design and use. So I think it's high time we initiate such debate here. We have finally we have two distinguished guests, speakers in this panel. As you see, we were also supposed to have Professor Jan Zeman, Vice Rector of Czech Technical University, but for some reason he is not here. So as Václav Moravec would say, we leave the chair here for him to perhaps pop up during the discussion. Let's see. Anyway, I would now like to welcome our two speakers. First one is Michaela Ligertová. Michaela is a biologist, university lecturer, and Vice Dean for Development and Quality at Jan Evangelista Purkyně University. Since 2023, she has focused on integrating artificial intelligence into research and education, partnering with Czech academic teams and research institutions to bring large language models into the full research cycle. So, Michaela, welcome here. And the other speaker is Jaroslav Anděl, who is a curator and conceptual artist working at the intersection of art, science, and technology. His work currently explores the cultural, philosophical dimensions of visuality, artificial intelligence, and data. He has organized numerous international projects addressing the relationship between art and emerging technologies, and authored the installation on the history of machine processing of data installed in the conference room. So you have already had a chance to see part of his work, and now perhaps we will also comment more on why and how he has developed it. Let's see. But before I give floor to the first speaker, which I would then invite Michaela to be, let me say that we agreed on a few questions which our speakers would first address, either all of them or some of them. Then they will have a chance to react to each other. Then we open up plenary session, and as you see, we are only 2 or 3 here on the stage, so we really rely on your contribution. And at the same time, there will be a deliberative platform set up for some parallel discussion and voting regarding the issues, ethical issues that we are currently facing in relation to artificial intelligence and robotics. But I will announce details on how to do it later. So let me just recapitulate the questions that our speakers would somehow address. Firstly, in the era where artificial intelligence is rapidly transforming how knowledge is generated, processed, and disseminated, what are the most pressing challenges that must be addressed to ensure responsible research and data production? So, very overarching question. Secondly, which ethical, epistemic, and infrastructural issues are most critical, such as data bias, transparency, reproducibility, environmental costs, very important. debate as well, or ownership. There are the biggest governmental gaps, and how should responsibilities be divided between governments, research institutions, which some of us represent, the industry, or the industry to ensure accountability, transparency, and importantly also public trust. What governance mechanisms, standards, or regulatory frameworks are needed to safeguard accountability and public trust? So we ask about possible more concrete measures. How can international coordination be achieved to address cross-border issues such as data access, sovereignty, or uneven regulatory regimes, both within EU and regarding EU and the rest of the world? And how can different disciplines meaningfully shape norms and practices around AI-driven research? So here, of course, I would be addressing Michaela as biologist, Jaroslav as a sort of artist, but also generalist, thinking across disciplines, and you from your particular fields. So, Michaela, please, let's start.
Oh, hello. Thank you for the introduction. And as you heard, the questions were extremely complex. So I did my homework and I prepared my statements, and the opening statements, I had to write it down, actually. So I hope you don't mind if I will read my responses to some of the questions, because I did not choose all of them. But I would like to start with where I actually stand in this discussion. And I see myself as a researcher first. I am a biologist working in biomedicine domain. Now I'm focusing mostly on computational biology, and AI is now a part of my daily research practice, and it has become a routine for me to use. I use Frontier AI, a state-of-the-art multi-agent system to write code, to reanalyze data, test hypotheses, search literature, but also to challenge my own assumptions. But I am not only watching this from the practical side. I am also Vice Dean at the Faculty of Science. I am AI ambassador at our faculty, and I sit on the National Working Group for AI for Universities, the nationwide forum. So I see the same problem from different places. As a scientist using this tool, as someone who's trying to help with writing the institutional rules, and as someone who's listening to the policy conversations nationwide. And what worries me is that these worlds are really not connected, somehow not at all. From my position, three challenges feel most urgent. It's the validation, access, and the missing channel between research practice and the policy. The most important thing I have learned is this. AI can now generate possible scientific findings much faster than we can validate them. Earlier this year, I worked with a multi-agent AI system to reanalyze public genomics data. The agents helped me find overlooked datasets, write bioinformatics scripts, and surface biological mechanisms that the field have missed, actually. Without AI, it would probably taken months to get to the results. That was exciting. But my honest reaction was not only excitement, but also quite a lot of discomfort. Because I could not simply say, the agents have found this, therefore it is true. I had to understand why the result was there. I had to check it, explain it, and decide what would need to be tested and audited, or also next made into an experiment, an actual experiment in the laboratory. And if I publish it, my name is on the paper, not the name of the model which is running the agent, the multi-agent system. And that was the moment that changed how I think about responsible research with AI. For me, the problem is not that the AI is useless or only a hype. This is clearly not. I have seen it find real things. The deeper problem is that AI changes what a scientific result is now. The result is no longer just a table or a statistical test. It also includes the model used, the prompts, the workflow, the data sources, the code, the verification steps, and the human decisions about to be trusted. Our methods, sections, and institutional rules are not yet built for that and to cover this. So if I had to name the first challenge, I would say generation is no longer the bottleneck, the validation is for now. AI makes exploration cheap, but confidence is still expensive. Understanding is still expensive. The scientific responsibility is still human. This is why transparency has to become more practical than just saying we used AI. We need something closer to an AI lab notebook as we are used to in biomed. Something that would log what model was used, for what role, with what data, what was checked independently, and where the human made the decisions. This is the record that will let another scientist ask, can I trust this? Is it reproducible? Can I challenge the results and the assumptions? That is the epistemic challenge. The infrastructure challenge is just as serious. Many governance conversations are about frontier AI systems, but most researchers in public universities and research institutions cannot access the frontier in a stable way. So we are writing rules for tools that many of us cannot run. We are expected to evaluate systems we cannot touch, and peer review work produced with the tools we may not have access to. And I think this is a serious problem because you cannot peer review what you cannot run yourself. This is not about wanting nicer and more expensive tools. It is about whether the scientific community has the capacity to check, contest, and reproduce AI-assisted work and workflows. The third challenge is one that worries me the most. No one is really tracking the frontier from the ground. Policy conversations happen at the level of principles, strategies, regulations, and risk frameworks. That level is necessary, of course. But the practical knowledge of these systems what these systems can and cannot do is being produced every day by the researchers themselves who use them in actual workflows. Those researchers see the strange failures. They see what can be delegated and what absolutely cannot be delegated. But the knowledge mostly stays private and silent. People are still afraid to talk openly about AI use in their research from fear being stigmatized. And there is no normal channel for sharing this practical knowledge with institutions and the policymakers. So policymakers and institutions are trying to draw a map. Practitioners are walking through the territory every day, but the map and the territory is not connected, are not connected for now. And the territory is moving very fast. We are in exponential now. That is why I think the governance gap is not mainly a lack of principles. So we have many principles as transparency, accountability, fairness, reproducibility, human oversight. The gap is operational. Who gives researchers approved tools? Who tells a PhD student what they can put into a model? Who teaches reviewers how to read an AI-assisted methods section? Who collects feedback from researchers who actually use these systems every day or every week? For me, responsibility has to be divided in a practical way. Researchers remain responsible for the claims they publish. Institutions should be able to provide access, training, approved tools, and clear rules. And government has to treat AI research to treat AI as infrastructure and not as an optional productivity tool. Finally, on the question of disciplines, I do not think norms will come only from the top down. They have to come from practice. Different fields now know what counts as convincing evidence in their own work. In biomedicine, a hypothesis is not enough. You need mechanisms, you need reproducibility, controls, and eventually biological validation. Other fields will have different trust tests. For me, one simple norm is this: outsource effort and not the judgment. Use AI to search wider, code faster, compare more papers, find hidden patterns, and challenge assumptions, but do not let it close the argument for you. The human still has to decide what matters, what is supported, and what deserves to be tested. So, the question I would like to leave on the table today is this: if practitioners, institutions, policymakers, and industry each hold only one piece of the picture, where is the channel that connects them? Who is responsible for building the capacity to track the frontier from the ground while is it still moving? I do not pretend to have any answer to it at all, but if we want integrity, accountability, and trust in AI-assisted science, we cannot only regulate from above and hope the practice will follow. We have to make practice visible, make validation teachable, and build infrastructure that lets the scientific community keep up. Thank you.
Just we move to the second talk and then we start discussing. So Jaroslav, please.
Okay, thank you for invitation and for an introduction. And I also prepare my introductory statement because I felt that questions were really difficult and complex. So I have chosen what I think was second question: which ethical, epistemic, and infrastructure issues are most critical? Data bias, transparency, reproducibility, environmental cost, and ownership. So, in my view, all of the above. The question is, how are ethical, epistemic, and infrastructure issues interrelated? Their interconnectedness present, and that goes to your question about who makes connection. Their interconnectedness presents a wicked problem to scientific methods and institutions, as they are separated in specialized knowledge silos. There are other features of scientific enterprise that AI deployment makes more visible and problematic. Take, for instance, citation metrics that originated in the 1960s in the field of library science to track sources in earlier publications and evaluate the impact of academic research. However, the primary goal of citation metrics gradually morphed from library science into hiring practices. This shift has been called a goal replacement. Now, in a short period, LLMs have resulted in a quickly rising numbers of scientific publications, showing that the prominence of citation metrics is perhaps good for careers of individual scientists, but not so good for science as such. There seems to be a similar process underway in the deployment of AI agents that, according to very recent studies and articles, may have grave consequences for our cognitive aptitude. To quote the Harvard economist Danny Roderick, and I quote, "When we allow AI to do our learning and thinking for us, we degrade our own human capabilities and risk eventually destroying the knowledge base on which AI itself relies. As a matter of fact, there is a very recent study published by MIT. One of the authors is Daron Acemoglu, most recent Nobel laureates in economics. I recommend that you find it and read it. The fact that very similar concerns were expressed a half-century ago by several foundational figures like Norbert Wiener, Joseph Weizenbaum, and Vannevar Bush, and then until very recently almost forgotten, begs the question why. I would argue that this inattention to the consequences of offloading cognitive tasks has been underpinned by a long-term process of decoupling values and facts manifested in the value-neutral notion of science. This separation has had shaped our understanding of science and technology, including key concepts such as data. I will say more on this specific topic later. Now, for three following questions, which are very much related, in my view, are too huge to answer in a short comment. They have been the subject of numerous initiatives, research programs, conferences, studies, and manifestos. However, there is a growing consensus manifested in a very recent initiative called, and again, I very much recommend that if you don't know it, you find it on the internet, called the Pro-Human AI Statement Declaration, published on March 4th. Facilitated by the Future of Life Institute, it represents a broad cross-partisan coalition of labor unions, faith groups, and civil society organizations, deliberately excluding major AI companies. This is really breakthrough, I think, because there were representatives of far left and far right, and they agreed and they reached this consensus, and this is really maybe turning point. Now, the last question, how can different disciplines meaningfully shape norms and practices? I would again emphasize the need for a multidisciplinary and transdisciplinary perspective that necessitates institutional and methodological experiments. These experiments can emerge in exchanges and collaborations across disciplines for which some computer scientists have called for. Such interactions don't happen out of nothing. They need multidisciplinary platforms and a long-term institutional support that has been lacking. And I just mentioned in this context that I have been trying to inspire creation at least one of these platforms in Czech Republic 10 years ago, and I approached a number of major players like Avast and so on. Always there is an initial enthusiasm and something happened, but there is no continuation. So back to this issue of data. Data's existence implies a conscious purpose, or on the other words, to quote the title of the forthcoming book by Dana Boyd, data are made, not found. This has several important implications. First, it implies that data originate in a specific context that includes their methodology, time, place, as well as their maker, producer, owner. These are data about data, that is metadata. They tell us where, when, who, how, but they don't say anything about why data were made. The question why is the question about purpose. The conscious purpose is what drives our thinking and acting. The conscious purpose implies a certain value system which is then implicit in data. In other words, data are latently value-laden. This finding leads us to the phrase between facts and values, which are used for the subtitle of the exhibition AI and Predecessors. And you see the one chapter in the back of this room. And yet, as I mentioned, their existence is predicated on a specific methodology, institutional context, certain intentions and purpose that establish specific potentialities. The origin of machine data processing by means of punch cards is a case in point. This technology, invented by German-American statistician Hermann Hollerith, resulted from a competition announced by the US Census Bureau in conjunction with 1890 US Census. The census included categories based on racial and gender hierarchies, a methodology used few decades later by the Nazi regime in Germany in the Holocaust. And this is, you find this story back in the installation. And I would like to close by this. There is a famous statement by Robert Oppenheimer. When you see something that is technically sweet, you go ahead and do it, and you argue about what to do about it only after you have had your technical success. That is the way it was with the atomic bomb. End of quote. This, however, is not just the case of the atomic bomb. An attitude in which implications and potential consequences of scientific research and discovery are an afterthought seems to be a characteristic of modern scientific research in general. In this context, the French philosopher of technology Bernard Stiegler recalled the story of Prometheus' brother Epimetheus, who only dealt with consequences of his decisions after the fact. While Robert Oppenheimer has been called an American Prometheus, he should be called Epimetheus, not Prometheus in this respect. Thank you.
So thanks a lot for opening. Now, in the first round, I would invite you to perhaps react to each other if you have any thoughts on that.
Perhaps to acknowledge the problem of the deskilling by using the tools and the cognitive offload. That's a valid worry, and it's something that worries me as well. And but I think, and I'm trying to experiment with building these tools myself, that we can actually use AI to support the critical thinking and to teach the PhD students how to reason scientifically correctly and so on. And I'm experimenting with building, it's a GitHub open repository, what I called research intelligence engine. And this is again a multi-agentic system that actually keeps the human in the loop, and it shows the reasoning transparently, multi-perspective analysis, and various types of how a student or a young career researcher can approach thinking about a research problem. And after each of the some hypotheses and next steps are proposed, and it's the student who is kept in the loop and must do the decision based on what based on the thinking substrate that the agents have produced. So the AI could be also a solution to the risk here, but it has to be deliberately built this way. And I hope that I can use this type of engine in my own courses and let the students actually engage with it to try to train their critical and scientific thinking. So this is just my small experimental approach to at least do something with the risks. And also sometimes we need to just inform the students that they have the option before they write the prompt, before they engage with the system, that they can either offload and, as I call it, lobotomize themselves by letting the tech doing the thinking for them, or they can ask how to think about the problem better. What is the meta perspective? If they are even asking the right questions about the problem, and this is the way how they can keyboardize themselves. So they always have the option to choose how they will ask the system and what will be provided to them back. So maybe a part of the responsibility could be also provided to the other side that is receiving the responses.
Well, you make a number of points which I have question about, but I have to choose just one. You mentioned that these technologies are now cheap, and that's what we heard in like first session today. But I think we should be careful here. We should think a little bit deeper, because they are not cheap, because they are enormous costs. We know about them: electricity, water, but also economic model, which is all based on. We know from like leading economists that this model perhaps is not sustainable. Many people just talk about that there is growing consensus. There is a huge AI bubble, and that it's the just question is when it will burst, not whether there is or there is not. There is definitely one, and these consequences will burden all of us. It's not that people who make these risky decisions and developments will pay for it. No, I mean, we have definitely historical experience, just going back to most recent world financial crisis, what happened then. So I think they are not cheap, and I think we have to be aware of it, and we have to think about it both individually and collectively, because if we don't, this risk they are growing will just grow, and it's not limitless. And that leads actually to another very important question and topic. You mentioned that we now are at exponential phase, right? And that's not only about capabilities, but it's also about questions. I mean, there is a philosopher, David Deutsch, who pointed out there are no new solutions to problems, but at the same time it creates new problems, right? And what is really a problem here, that there is this acceleration of questions which are not addressed at all, and we see that we don't have tools, we don't have institutions how to address them. So I think question of acceleration is here critical, because if you follow what these interviews with Dario Amodei and Sam Altman and other kind of guys, they often talk about this acceleration, but they say, well, it's just the fact. We cannot do much about it. Because there is China, there is competition, and we don't know what to do about it. And I think that it's not really true. I mean, I think it's in their interest again to be in this game because they have vested interest in this. So I mean, there is again growing activity, interest in the question how we can slow it down, but so far has not been successful, and has not been successful again because this complexity on the one hand, on the other hand, what you pointed out, that many things are not connected.
If I just may comment on both of you, actually, thanks for bringing up the issue of cheapness, or rather the cost of the cheapness for the end user, because I think that in many respects you are right, and especially the environmental costs of AI are really becoming a huge problem. And in a way, if we stay with the metaphor of this is cheap, so it's cheap in a similar way as our food is cheap, but actually the costs are externalized to third countries, environmental pollution, you know, things like that. So I think that bringing this hinterland on the stage is truly important. And I think that if we just, you called for an experiment, so I think it would be great for each of us when we use AI, either for big tasks or small tasks cumulatively, to kind of make our own account of what environmental costs this creates and whether it's worth producing this collective burden while perhaps benefiting individually. So that's I think one really huge issue. Regarding the debate on deskilling, what I find really interesting is what the kind of debates which are currently happening in medicine. Because when you open pages of any major medical journal, or they really debate the use of AI within medicine and clinical practice in very salient and practical terms. Because unlike in science, where of course I agree potential deskilling is or not skilling is problem, it does not show up, it does not translate immediately into harming concrete other people. While in medicine, when this happens, it's a huge problem immediately, and it harms your patient. So I think perhaps I think in this respect, the debate within clinical medicine might be more advanced because they necessarily were pushed into addressing these issues even earlier than us researchers, scientists who, can speculate about what may happen in a year or 2 years, but we do not harm anyone with this immediate effect.
First, I wanted to address the environmental issue. Yes, of course, I meant it as a metaphor that the generating the results is cheap from the point of view of the capacity of the researchers, like time capacity. And I acknowledge the environmental problem, that this is real and has a huge impact. But we also need to differentiate the energy needed to train the models and separate it from the energy needed to run the models and to generate a response to your query and so on. They are related, but it's still a little bit different. And the question is if really each of the researchers should have bad conscience about actually writing a prompt and using the tools to improve research, to save resources, maybe to plan better experimental design and so on. On the other hand, we are not having any information about how much it actually really costs. There is no quantification, there are no real numbers, so it's very difficult to measure actually how much energy are we really using when we are using these tools for research. What we know that we should have bad conscience from using cars and driving individually and so on. So yeah, it's not only a question of using AI and AI tools. And but I agree that the training of the large runs and the whole life cycle of the GPUs and everything and the data centers, it's a huge problem. And yeah, you are totally right. About the skills of the doctors, I think that the skills among the doctors are distributed by the Gaussians, you know. So there are doctors which are great and can seriously help you, but there are also doctors whose skills probably are not that great, and those would benefit from using the AIs, and their patients would benefit from using the AIs. And if I could choose a doctor, I would probably nowadays visit a doctor who is using some kind of state-of-the-art AI. I would deliberately go and want the doctor to consult the new algorithms, because
I mean, so, just to clarify, I was not suggesting that either we should not use AI or feel shame that we do it whatsoever, or the doctors should not use it, but that we should be using is possibly with the awareness of the costs and kind of accountabilities towards ourselves, community, humankind, whatever, about those costs and whether they are justified. That's all. And the same with the doctors. I mean, it's clear that in medicine it has a hugely positive role to play, but under, you know, specific conditions.
Yeah, right.
I would like to go back to one topic you mentioned about this upstream, downstream, or was it you?
Yeah, I think I used that.
But I think you also touched on this topic. What I think we forget that and that was your point, that most often themes of responsibility, ethics, and all these questions are always addressed when it's basically after fact, when technology is already established, and so what you can do then. I mean, that's the case with social media, and we have seen what very negative consequences it brought, and we see it also with chatbots, because one of the chapters in this exhibition is story of original chatbot, which was called Eliza, created by Joseph Weizenbaum in the 1960s. And it's a very interesting, but also it's a warning, and that's what when he created it, and it was much simpler technology than in the 60s. That people thought that there is conscious being in that program, and immediately it was used for therapy, and Joseph Weizenbaum was horrified. There is this anecdote he talked about that his secretary used ELISA, and she knew what is the technology about and so on. Still, she asked him, Professor Weizenbaum, can you leave the room because I would like to use ELISA for private conversation. So this was really shocking to him, and realized that this is a huge problem. He started to address, and since the late 60s, he actually focused all his energy on this topic, our relationship to the computer. But he became basically outcast from AI community, computer science community, because of his critical attitude. And he was for a long time only voice who was very critical. He published a book, and if you read his book, Computer Power, I won't quote precisely, Human Reason and Computer Power is the title. You see that he saw many issues coming, which now computer scientists, after many years, are discovering his work, and he warned us, and it's very curious, mind-boggling, I would say, that something which was obvious to him, and he warned, and he worked, and still society did not listen to him. And now we see all these issues emerging, and it's getting very serious. I mean, you all read the stories about suicide and mental really issues, and megalomania, you name it. And we still don't have precise data about this, but I mean, there must be, because there are hundreds of millions of users. So again, after the fact, and the point is that this consideration should not be, as you pointed out, something we think after, but at the beginning. It should be part of our education, maybe even in secondary education, and definitely in higher education. What we have is that people like at technical universities, they are not exposed at all to these questions and issues, and I think it's a grave error, that it should be really changed, that you don't need to specialize in everything, but you can get introduction into some of these issues. Some universities in the West actually are starting now doing it, but I think it's about time we start doing it something like that in the Czech Republic.
Mm-hmm. Thank you. So I think it's a good time to open up the floor for any questions, ideas, suggestions, observations. Yes, please.
Thank Thank you. Patrick Španěl, Academic Council, Academy of Czech Republic. This was wonderful hour to listen to you. It was like watching a ballet performance, and so many ideas, so much philosophy. So I have to admit it was hard for me to keep the attention and to remember all the ideas which were mentioned. So I hope you can actually share your written scripts with us at some point, because it will be so useful to use an AI tool to get a summary of each of your talks in bullet points. But let me just ask a question back to the title of your session. Responsible research and data production in the age of AI. One idea I picked in your discussions was the idea of changing role of scientific publications in science. You mentioned the method sections are, Dr. Ligertová mentioned, the method sections are missing really the intermediate steps of how AI tools are used. Dr. Angel mentioned that all science is a data science. So I would just go straight to the point in the question. Do you believe that the time is coming that the data sets should be actually used in evaluation of science, both in the sense of career progress of individuals and in actually assessing the value of science of the groups, institutions? So let me just rephrase it. How do you think the creation of data sets should be evaluated in evaluation of science?
Well, I think it's a very difficult question, and it's difficult because it goes back deep into the past. AI actually made this problem much more visible, but it was there, and I was talking about goal replacement, because the original purpose of the citation index was something different, was created in the field of library science, and gradually it was instrumentalized for very different purpose, and so it built up certain attitudes in scientific institutions who again had vested interest in this system. And if you go through the history, you find that there were critical voices, and if you talk to, I don't know, almost any scientist, but at least that's my experience when you talk to scientists talking about these practices, they complain about it all the time because they know various tricks how you can kind of enlarge your index and many different techniques what you can do. So again, this is like you would have to address this issue first, because again, what AI does, not only in this field but in many other fields, that it accelerates and it amplifies. So if you have, I mean, it's a problem of dynamic balance. So if you have a certain system which is very complex, like let's say functioning of science or society in general, there are always some problems, but usually institutions have tools how to address those problems. So there is always some imbalance, but you have tools how to address it, right? But now something like AI comes in and amplifies first these negative problematic aspects, right? And now society does not have those tools because, again, there are different temporalities. you create ethical standards and all these issues in time. It's a slow time related to fast time of technology and science. So why is that? Because we have not created, again, institutions, instruments, how to connect them. And so we have to start first thinking about it, identifying, and then we can really address it, yes? So I think this is something what scientific institutions should do. They should organize discussions, not just one discussion, because it's a difficult problem to address this, and it would take time, but I think it will be worth of that time.
Okay, maybe let's try to go more directly to the question. Even though this larger reflection is important, but I think, as I understood the question, it was whether creating data sets, and maybe here I would add data sets including what kind of metadata and so on, with what kind of attributes should be recognized as valuable scientific output, right? Comparable to a journal publication or book publication, or yeah.
Yes. I have this guilty pleasure now with the agents that they are able to quickly look for public data and biomedicine, bioinformatics data sets, and actually compare the metadata against the data. And if it's telling what it's really saying, and let me say that it's a mess. I have the feeling like there is no clean and perfect data set. But also, I would prefer just to make a fat line now and not really dig into the old data set, because that was already done and can't be saved. And maybe from now on, let's agree about how to do it right. And this is somewhere where the AIs can actually help us, because we can iterate quickly. They can audit the data sets. They can audit it against the metadata, help with the structure and everything, and it can be done fast now. So we maybe have the tools now to do it right. The question is to agree about what does it right mean. However, I would not dig very deep in the datasets that already exist, or a lot of us would need to give our titles back and so on, and retract a lot of work. So, yeah, that's it.
Okay, so I understood definitely you would not advocate for straightforwardly including data sets production into as an item recognized on CVs or in research assessments, but
well, I think it will happen, and there is a plan actually that there will be a scoring system from AI algorithms that will immediately evaluate each of the publication that was published based on some scale on how reproducible and trustable it is. Because now we have the capacity and the compute to actually very quickly differentiate which of the publications or the methods and were done right and which not. So this will probably naturally happen, and everyone will be scored. And I don't know how we can retrospectively make out of it, but it will be visible in the publication databases, in the datasets. There will be some kind of, you know, like percentage or some semaphore or something like that, how much trustable your data are. You can do it with even with ChatGPT and some of the advanced subscriptions. You can run a reproducibility check on a paper for a paper which was already published, and there are people who are enjoying actually doing this to trying to find and identify mistakes in statistical methods and so on. So I think this will happen naturally. The question is what we will do with that. But what I would like to see in the future, it's like, okay, let's make a line, and from now on, when we have the tools, let's make it better in the future.
Marco, please. Go ahead.
Yeah, this is interesting that we will be evaluated by AI. As an experimentalist, I would like to know how AI will know how I did my experiment. That's I don't want to be expressive. It's good to say that we actually have dataset as an output. It's so-called T type of output, already approved by RVVI, or how is it called, this body, and it's from January 26, January 1st, 26. I don't know if it's good or bad, because as with publications, as famous Coffee Mlanek, data can be generated relatively easily using or not using AI. So whatever this is about the rigorous approach, how to, as I said, how to evaluate my experimental data, it will still take time to be, I'm not even sure if it's possible, but everything is probably possible. So I don't want to say what will be in 5 years, but as of today, if I am immunologist, if my cells were prepared properly or not, no one can evaluate. I can evaluate it as the person who did it, but in the data, it's very difficult. No, pretty much no way. As I said, as of today, as of right now.
Thank you. Any other either questions, observations? Yes.
Maciej Haranczyk, I have a question to you, Michaela. In your introduction comments, you mentioned access, that some researchers might not be able to access the AI to verify. And so I have an ethics question. I was recently asked in my institution if we should provide our PhD student access to more advanced tools, which are expensive, and of course the cost is a issue. So on one hand, I thought everyone should have an access, but then practically it will cost so much that maybe we cannot afford. And you mentioned your other role at the university where you promote AI and think about it. So I don't know if you can share any comments on the access and providing access to students.
What we agreed is that the faculty will not provide some central solution, but each of the department is free to use its own budget to buy any tools they want. And with the data privacy and so on, the team licenses are preferred in this setting. And I always advocated for the students, at least in the library, there should be 3 or 4 computers where these, the most expensive frontier AIs will be available, and there could be some shared form or something where the people can apply for the time to share with the research with the tools. But at least it will be somewhere accessible for those who really want to try and to run some work with it. So yeah, we definitely do not have money to provide to everyone, but we can have at least some places dedicated computers where the subscriptions will be running, and anyone who has not everyone needs it, not everyone is trying to solve something really complex, but in the moment you have, then there should be this one computer in the library or somewhere at the faculty where you can interact with the system.
Marie Schaffner. I want to go back to the method section as admitting use of AI within the research for whatever purposes if it's outside the copy editing of an article. Are you aware that any ongoing discussions as to how the publishers are going to view such statements within the papers? Because let's say European Commission published a paper on the responsible use of generative AI in research, and the first point for the researchers was if they're going to use the AI in their research and for data analysis or whatever way which is going to be reflected in the results, they have to state that in the method section or other different sections as relevant and or stated by the publisher. But from the institutional perspective, saying to the institute of researchers, you have to state such a fact in the method section. Is this going to be acceptable by the publishers? Are you aware that there will be any ongoing discussions like that?
If I may, because this is a huge pain point, there is this shadow zone, because as a researcher you are supposed to transparently disclose everything, and in the rules of the publishers usually there is this small sentence that the editor can that the editors could decide when the use was already out of the scope of what is allowed. However, there is no line drawn, and I am afraid that the editors and the reviewers are not AI literate enough. They might not have experiences with the tools from the practical perspective, and that there is, what I see a lot of researchers are afraid to disclose the use properly, and it's a huge mistake, because I think this is where the good and the bad practice should be made visible and shared, so the whole community could learn from it. So now it seems like if you disclose, you can be punished. However, this mindset should be changed, like you should disclose because someone can learn from you how to do it right, or the opposite, to let you know that actually you are not doing it right, and so on. So there is this huge opportunity being missed by the publishers, and I hope this is going to change soon, because we need to normalize the use of the tools in the research, because the positive effect is now like evident.
Thank you.
If I can just remark, well, I am following what's happening out there, and it's interesting, first, how fast it's happening, and second, how very different opinions often on the very opposite sides, even voiced by leading protagonists, the leading actors who cannot agree on really fundamental issues. I think this will be in the future, it will be a great subject for anthropology of science to study. But I think again,
it
already is, yes. But there is one challenging aspect, which is again this speed and acceleration, because what you are saying, eventually it will be. But it's the question, because there are new technologies coming out, and that changes rules and changes opinions and so on. So it raises question where it will end, because it's not limitless, it's obvious. And I think we should also ask this question. Because my artistic background, I would like to draw a parallel here. To be a modern artist, modernism, it was defined by that artists should actually study their medium, and that their work is about the medium. So that goes to Marshall McLuhan point, the medium is the message, right? But since maybe late 20th century, this becomes a big problem because, again, because of technologies. And so you have these technologies of representation from photography to cinema, and then you have video, and then have you new media, and so this just cannot work anymore because there is a new technology so often that you cannot study your medium like what painters did or sculptors did, even photographers could for many years, but now and that was one of the reasons why this notion of postmodernism came about. So I think we are not asking this question about speed, how to address it, what to do about it. And I think we should, we have to, because it's really something which impacts really almost everything.
Thanks. We are coming to close of this session. So maybe as the last possible interventions, I would ask either both of you or anyone from the audience to come up with a very clear, concrete step that you would see as both necessary and realistically implementable in the Czech Republic now to improve integrity around and of AI use in research. And feel free to maybe, put on table some good practices you could spot internationally. You mentioned that some foreign universities really strongly integrate education around instruction around ethics and this kind of issues into technical education. Whatever small issue we could put on the table, and we could perhaps try to implement here and now.
Well, I already mentioned one, which is creating, first maybe something very simple, a platform which would be on a regular basis, where people from different fields and interests can come and have conversation about many issues which are out there. And this can generate something much more concrete and productive. But first, we have to really create community of practice, which means people who share concerns and experience, and from that always many important things are coming out. And plus, and this should be also part of it, and we did not mention it, is also democratic dimension of science, which often is ignored, but I think it's extremely important because science, of course, is domain of experts, but we should not forget that it's about knowledge, and knowledge is not just property of science. I mean, it's something very human, and I think, as you know, there are concepts of citizen science, and not only that, there are deliberative practices coming to science, and I should mention here coordinator of this conference, Michal Trčka, who is trying actually to promote and start these practices. So these are two examples, very concrete, I think very important ones.
Thank you, Michaela.
I have one practical, this is such a dream of mine, that each institution would have something like an AI hub, where there will be few selected researchers and students that will just will be provided with the frontier tools. They can choose whatever tool they want to experiment with, they can benchmark it, and they will focus on to monitoring the frontier, the development of the frontier agentic systems, autonomous AI researchers, and so on. And they will log everything, and they will share and feed the policymakers and the institution policymakers with their observations, with the failure points, and so on. And this is the only way how we can build some informed governance, I think, for the future.
Okay, thank you. And thank you for accepting invitation to this panel and contributing all your thoughts. There were some requests that you could share later your initial talks with the audience, so we shall later try to ask you for that and mediate to everybody who was registered at the conference. And we also, as Jaroslav now mentioned, we would share results of this small experiment in deliberation on some issues. I don't think we really have time to dig now into that, but the idea of this very technology is that it would enable mapping opinions in communities, either on site or offline, and on particular issues, and then use these results as possible, prompts for further discussion, which we, however, do not have time now. But we will definitely use the results with share the results with all of you, and hopefully it will also provide, become prompts for your either individual future reflection or some debates in the communities, which I totally agree with Jaroslav, are really crucial that they continue in the future and become in some way institutionalized, even if informal, in terms of some informal platform. So thanks again. Let's thank our speakers. And I think that this makes the very conference. Oh yeah, we will have some formal closing of the conference by my colleague from the Academic Council.
Thank you. So let me start first by answering Teresa's last question. What shall we do? I can see now one thing we can do in the Academy of Sciences, and it's to change the incentives for research. We should not provide incentives just for producing the papers. It's actually looking into the history. We all in universities, academy, improved the quality of Czech science maybe 10 years ago by learning to publish in high impact journals. It was obvious. We now publish in Q1, D1 journals. We are all familiar with this idea, but this time is gone. It's not good enough anymore just to produce more and more publications in Q1, D1 journals, and it will be institutionally painful to go away from these metrics, because so many of us, including myself, learned to enjoy the pleasure of having an article published in respected journal in our respective fields. This will have to change, and I don't know how, but we have to change the incentives, because otherwise we are providing the incentives to publish work which fails to reach the best scientific good practice, which may be prone to fabrication, falsification, cherry picking, you name it, all failures in good scientific practice. And now we have a good window of opportunity. We have a new RVVI composition, we have new government, and we can actually change the system of evaluation of the Czech science, as long as the universities and Czech Academy of Sciences will actually pull at the same end of the rope, as long as we see our common goal in doing science. So, question I'm thinking constantly about, why are we doing the science? It would be for a whole separate lecture, but let me just say, we do the science to make our Czech society stronger, generate new knowledge, but mostly generate the skills amongst us, amongst our students, to even keep the pace with the development of the science. And just on a personal note, I'm a little bit skeptical towards the idea of attracting, or in Czech, lákat, foreign excellent researchers by money to come to our institutes to work for us. I know it's for a separate discussion, but I really believe it's so important to educate our own students in AI, in science, and in everything. So this was just my answer to Teresa's question, and let me now close the meeting. This was an amazing opportunity to see what can happen when social scientists, people in background in humanities, philosophers, get together with experimental scientists, data scientists, biologists, and whatever we are. And it rarely happens. And this is, I dare to say, being part of the AMULET project, which is surely scientifically important in two-dimensional materials and all that. This alone is such a useful outcome of this project that it cannot be underestimated. And this is a number 2 in this public hearing series, and I hope more will come as an opportunity to meet. So on that happy note, I would like to thank all the speakers. I would like to thank all the moderators of these interesting discussions, and I also thank, of course, the organizers. I know Martin Trčka and Martin Kalbáč, who is somewhere gone. Also, I want to thank the president of Czech Academy, Radek Pánek, for genuine support of these activities, and also thanking Scientific Council, represented by Secretary of the Scientific Council, Diana, at the back, and of course, Chair of the Scientific Council, Pavel Beran, again for the genuine support of this forum. And I can assure you that whatever will come in the written form as the minutes of this meeting will not be lost. We will put it through our favorite AI tools and make an executive summary out of it, which will be used in policy making. So thank you again.
I think that's all. And I would like also thank you, all of you, and cooperation with CIIRC and technical support also. Mirka Macháčková, namely from Heirovský Institute, from CIIRC also Jana Bilíková and Alena and Eva Doležalová and all of guests, speakers, participants, audience, and finally, maybe one another occasion for discussion is a revision of science. This is also conference with support of AMULET project at the Institute of Physics in June 11. So this discussion will be about research data management, and future of evaluation and assessment of science, not only at Czech Academy of Sciences. Thanks a lot for your attention and for your energy during this day.